Getting ready to go? Very good. Okay, welcome to the April 14th, 2026 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week for me, I've been cleaning the house, or cleaning the Radio Shack, and mowing the lawn for the first time. So it's we've been having a lot of we had not much precipitation over the winter, but we had a lot in the last month or so. So stuff is starting to grow. So that's about it for me. Next on the list is Nathaniel, W2NAF. Go.
Thanks, Dave. Just same as usual, trying to keep everything going. That's what I'm doing.
Very good. Next on the list is Paul Elliott. Go ahead,
Okay,
Paul.
thank you. Tomorrow I will have my X88 design review document ready to share. So that's my promise. You can get a free kick in the if I if I don't deliver, but I plan to. But to be honest, I've been working mostly on my little time sync board, um, getting this filter stuff done, characterizing the output driver at at various voltages and using I got an well, I won't show you the pictures, but they're pretty cool, trust me. Raised cosine filtering on the not the sine squared stuff or cosine squared stuff, but anyway, raised cosine filter on the amplitude control. So the spectrum, the spurs or the excess spectrum drops off pretty quickly, but we still get a really nice response. And again, I can do one kilobit chip rate on a spread spectrum pattern, or much slower than that if we decide. So that's something that Scott and I think need to talk about, and anyone else that's interested. And of course, it brings up a bunch of other interesting questions. Does anybody really want to do this timestamp transmit stuff? Uh, I think it'd be a good idea, but that's just me. So anyway, so that's and this coming Wednesday, today's Monday, so Tuesday, then Wednesday, I'm on the road for 2 days, heading back up to Friday Harbor, and be continuing all my work up there. I was hoping to get a new antenna that I could use because we moved the receiver up there to my place up there, and it's not as quiet as I would have hoped. Um, I don't know. I'd like to talk about one of the new or vertical dipole probe antennas that HamSci has been using, because maybe if I installed one of those, I got a better location. I think it might work better. Okay, so that's it for me. Back to net.
Sounds exciting. Lots of news. So, next on the list, we have David McGaw in 1HAC. Go ahead.
Give me a moment. Oh, good evening, everyone. Um, Nothing new to so much, except we did have a good meeting for the cinema movie project this afternoon. Sorry you weren't able to be there, Nathaniel, but we did use your name in vain. Um, but yeah, things are moving along, and of course, I've got a another presentation on it scheduled for the Hamvention. Um, Looking forward to that, hoping that maybe Christina will have some of her um, visualizations available to use in that. Um, and I'm moving along with our ground station. I now have two systems running, one at the house and one at Dartmouth. Soon to put up our rotator and see if we can point a big boom antenna at our satellite. Up until now, I've been using an egg beater, which works up to a point, but for some reason, that satellite has a very widely varying signal strength. It's just got a little quarter wave antenna that's apparently usually pointing away. um, Sometimes I can get the beacon, sometimes not. But then we'll be working on high power transmitter to command it so that we can act as backup to Montana. And so that's about it. Oh, we did have, by the way, another presentation about cinema, movie, and HamSCI. We had an open house at Thayer School, the our engineering school here at Dartmouth, and Eric Hansen, who is our the um, trustee of our radio club and also professor now emeritus. Um, and then, so we had a presentation on FT8 and on Aries and on HamSci and movie cinema. And we had a number of people who were getting interested. Sometimes kids, sometimes adults. And however we get people interested, it all works out. So back to net.
Very good. Next on the list is Franco, K4BZ. Go ahead.
Hey, good evening, everyone. I'm just here to learn all the good stuff you guys working on, especially Paul and then later Tom, because I'm very excited by their project and ready to help for the software and everything. As usual, I've been busy with work over my head. Last week, and I was mowing the lawn too, and putting together a grill. So I haven't really had much time to work with that. I'm working on a cable for the FT891 to get it connected. So that's my big project for these days. Back to you, Dave.
Okay. Next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
All righty, people. Good evening, everybody. This is the first HAMSA I've had since getting back from the conference in Connecticut. Really had a good time there. And afterward, I not only got to see family that's scattered throughout the East Coast, got to go to a professional meeting in Rhode Island. Also, I made it a point, got to get back to 225 Main Street, Newington, Connecticut, and spent a day and a half operating W1AW. So that was really, really fun to do that. And then as part of this trip, near the end, I was in Washington, D.C. at the National Air and Space Museum, and they have on permanent display there the backup, the flight-ready backup for Oscar 1. It's on permanent display there. So combine Oscar 1, seeing it, photographing it at Air and Space, and then, of course, there was one of the backups of Oscar 1 at HamSci, which was brought over from its permanent home at 225 Main Street, Newington, Connecticut. So that was really interesting. Had a really good vacation there and a really good time playing ham radio at W1AW. So I finally got back, finally got all my laundry done, and finally figured out that this entire road trip, I drove 2,300 miles round trip. So with that, 73 to all, and hopefully see you at the pilgrimage in Ohio at the third weekend in May. I shall be there, and hopefully we'll see you all. We're wandering around somewhere, and if not there, then at the HamSci forums. 73 to all, back to net.
Okay. Next on the list is Clint, uh, K7 OEI. Clint, you're muted.
Here we go. That should got to select the right microphone. Anyway, and unmute. All right, yeah. Mostly been doing some radio related writing, but uh, I missed last week because radio things. This weekend, I guess the project coming up is get a climb up to a tower and then climb a tower that's on a tower. The Ham Club has a 20-foot Roan 55 on top of an AT&T long lines tower with a log periodic, and we got word that it shed one of the elements this past winter, so use a sky hook to lay the thing down and work with the antenna and raise it back up again. So it'll be all kinds of fun. So I guess that's what I'll be up to. Anyway, back to you.
Well, have fun with all that. We appreciate everything you do. Next on the list is, let's see, Dave H, W6OQ. Go ahead.
Yeah, good evening, everyone. Just enjoying my dinner here, so I don't have the video on. Only working on my taxes this week. That's it.
Oh, I was glad I got that done. So, anyway, next on the list, let's see, is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. It's been quite a busy week for a VLF natural radio and amateur transmissions. So for whatever reason, in April, there's an uptick in whistlers. I have received on the Whistler catcher test system that's currently running, definitely living up to his name. Definitely living up to its name. Captured at least 10 or 15 whistlers the past couple weeks. In April, there tends to be an uptick, and the question is why. Never really understood, but this seems to follow other locations of similar latitude. Also, an uptick in the spring and fall. And
is storm activity increasing? I mean, that's one reason. It's spring.
Well, that's definitely part of it. But we don't see an uptick in whistlers during the summer. It's usually the spring and the fall. But yeah, there is increased thunderstorm activity at the conjugate points, but nonetheless, that's an interesting science question to investigate. So aside from that, some VLF radio amateurs have been activating the 8270 and 5170 hertz bands with transmissions. So that has been excellent. They're mainly sourced in Europe, but there's so much noise on the VLF receiver now that it makes it very difficult to pick up those transmissions. So that's unfortunate, but there is definitely activation of the 5170 and 8270 hertz bands. I've been working more on the end panels and 3-channel version of the interface board, and I also had a conversation with Nathaniel regarding some of the logistics and work involved in the current phase of the movie project for Cinema Movie. So that was good. That was really interesting. That's definitely moving forward So, but other than that, that's all I have. Back to the net.
Very good. And next on the list is Michael Howen, AC0G. Go ahead.
Good evening, everybody. I've been pretty busy this week. Been preparing the QEX paper for submission. Been working with Rob pretty extensively trying to get version 4 of and the next iteration of HamSCI application going. It's not Whisper Daemon specific anymore. We've ended up renaming it to Sigmund. So we'll see how that goes. It stands for Signal Monitor Daemon for HamSCI. So hopefully that will be a kind of overarching framework for us to include different clients, swap them in and out, but to remain stable and help coordinate everything. I've developed in that regard. We're working on converting Whisper Daemon to a new client format. I've created a recorder for Whisper Daemon. I've also created a recorder for PSK that runs like a client in the same fashion. And I was just checking the pskreporter.info and the local machine I've been testing it on here is successfully making reports in that regard. And burning up a lot of AI tokens with Claude because Claude is integral to our ability to succeed in this. I also mentioned to Paul I'd like to get one of his HF injectors so that I could confirm the software package that can receive it and use it to standardize the time on a local system. The nice part about all this is Rob and I are writing it in a way that should be pretty modular and maintainable, and the clients can run independently of each other or under the aegis of Sigmund, and hopefully will be really well documented and modifiable and improvable by anybody who cares to look. So yeah, made a lot of progress this week, I think, though. Back to net.
Very good. Next on the list is, we already talked to Paul, so I'm going to go to Scott Newell in 5TNL. Go ahead.
Hey, not much to report, although I did get an email from Infineon. I guess they're doing an FX10 webinar on May 5th. So Paul, Tom, Franco, if anybody didn't get it and wants it, I'll forward it to you if you need it. That's it
Thanks,
for me.
Scott.
Very good. Next on the list would be Tom in 5EG. Go ahead.
Okay, I didn't expect to get called so quickly. It's been a busy week. Franco gave me a pointer to use the board support package software. So I updated Modus, the Infineon tool for the FX10, and played with the BSP for 4 or 5 hours, and I think I got the hang of it now.
Low audio, Tom.
No audio?
Low.
Low audio, is that better?
Not really.
Oh my goodness.
There you go.
Okay, I can swallow the micro. I'm having some problem. Firefox is crashing about every 2 seconds here. So I played with the board support package for a couple of hours and got the hang of it, figured out how it works, and generated first. The FX10 is very flexible in terms of all the I/O pins, how they can be connected to peripherals, and where they can come out. So took a stab at setting all of that up. It generates a bunch of C header and C code files that you can incorporate into your project to wire up. It's almost like an FPGA, in that all the IOs can be programmed as to type and strength and a lot of different things. So I got a package out shipped. I'm working on the schematic, getting close to having the next schematic done. It's sitting about 17 pages of schematic right now. So pretty good design. Back to the group.
Very good. And then we have Rob Robinette. It sounds like you have a lot to talk about.
Oh, I think Michael has largely talked about it. It's we're deep into developing what is we're now calling Sigma. Um, the I do
Rob, you also have low audio.
There you go.
I don't think I think the problem's at your end. I heard Tom very clearly at my end, as at the same level as I hear Dave. So I don't think it's mine. Uh, so I'm seeing. I don't know. Anyone else have
You're okay.
Rob, you're coming through fine, and
You're
you're a
fine.
little bit louder now than you were, for whatever it's worth. But
I'm
sounds good.
shouting. I guess in response. I'm sorry. I don't think there's anything. I could turn it up, but I think it would distort my audio. Um, anyway, we're working through this is a major complete revision of the data flow and the software architecture. So there's lots of debugging to be done, left to be done. But I'd say, maybe later this week we'll be ready for alpha testing on this. I do think we did observe one thing today. I'm not sure if it also explains it. I noticed, Phil, that in Radio D, in our version 4 testing, that we're using the latest version of your Radio D. And I'm noticing that in the log file that Radio D assigns both the FFT and the RX888, the proc threads to the same CPU, not just the same core, but the same CPU. So they end up on CPU 0 in this case, and there's not enough CPU time on that to probably run both of them. Plus,
I don't do that unless you tell it to. There's an affinity flag in the config file, but you probably want to turn that off for now. All that does is say, keep me on the whatever CPU you're running me on now.
yes. Well, let's see. Okay. Well, I'll go look and see if
Otherwise, I leave that up to you. I don't like to put in, I don't really like to put in affinity stuff when I don't know what I'm doing.
Well,
For just this reason.
Yeah. Well, let's see. Okay. Well, maybe that we're instructing you wrongly. We have Sigmund, which is controls everything in version 4, is the one that understands all of the processes and services that are running. So we've made it its responsibility to assign the CPU affinities.
Okay. Yeah, there is an affinity flag, but all that does is say, keep me on whatever you're running me on now. And that could easily cause the problems you're talking about.
Yeah. So, well, that's
check that,
okay.
make sure it's off.
Okay. Well, that's, okay. Well, I'll look at that. I'm looking at it right now. Other than that, I don't, we can talk about other things, but, I think, yeah, let's see, affinity. It says affinity equals true. What do you do when affinity equals true?
I just told you, it looks to see what CPU is running on and then says, keep me here. And that's for the FFP.
Okay. Previously, what you used to do is, you in several check-ins previous to this, I would see you would put FFT on core 0, and there would be a line in your log file where you go CPU, FFT equals CPU 0 and assign proc to core 1. And I don't see that anymore. I'm not explicitly saying which.
All right, I'll go look at it. I haven't looked at this in a while.
Okay. So
I had a few more comments I wanted to talk about the priority inversion stuff that I fixed last night.
yeah,
Dave, I don't think you called on me.
Oh, I'm sorry,
yeah.
Bill.
All right. All right.
Why don't we call on you next?
Better late than never. Yeah, okay. Yeah, I ran into a problem, and it's anybody somebody else anybody else who's running this, please let me know. With some Linux kernels, not all, but some, specifically 6.12.74, which is the most recent real-time kernel, 74-RT, the most recent real-time kernel with Debian Trixie. Um, I was losing samples very badly on my RX 888. And that thing has been running faithfully for years. And I had just done a kernel upgrade, and I figured it probably had to do with that. So I went digging, and sure enough, the in this case with that code, running a real-time kernel ironically makes the problem worse. The reason is that in the standard kernels, IRQs, interrupts, are handled at interrupt time, interrupt context, extremely high priority. If they're not masked, they get serviced right away. In the real-time kernel, to minimize the amount of time you spend in interrupt context, things like IRQ handlers get moved into real-time threads that run a process of priority 50. And I was running some of my tasks like the FFT and the input at like 95. So they were getting unconditional priority over the routines that were servicing the USB from the ARX 888. So I changed everything so that all the threads now run at 40 by default. You can change that. The FFT runs at 41 and the input thread runs at 42, and the problem simply vanished. So I definitely had a problem there. If anybody's run into problems with severe data loss in certain real-time kernels, just update to my latest stuff, and it hopefully will fix that. Let's see what else I've been doing. I've been working, implementing a lot of ARDC 44-net tunnels. Makes it much easier to get to the machines that I manage, especially when I want to do it from multiple machines, because I can give them ordinary routable IP addresses and just reach them like any other site on the internet. If anybody needs help in knowing how to do that, let me know. This is a free service that ARDC gives back to the ham community. If you're a ham, you have a legitimate use for it. The whole thing is free. What they will do is they will assign you a network 44 address, a routable IPv4 address, either a single address or a block. Although if it's a large block, you have to justify it. And then you set up a WireGuard tunnel between your computer or your router and ARDC's points of presence, and then you can now be contacted on that network 44 address. So it's wonderful for getting around NATs without doing port forwarding kludges and stuff like that, especially if you want to do UDP or do anything non-standard. So I've been using it on a bunch of the sites that I maintain, and it's really quite nice. So let's see. Other than that, I'll probably think of something else, but that's all I can think of right now.
You should caution people if they want to use 44net that they are responsible for the network security.
That's right. Yeah, you are exposing yourself to the world, but there's a very simple way to control that. And I can, anybody who's interested, I can go over to the details.
Yeah. Unfortunately, we did a scan of a portion of the, of 2044 net addresses, and over half of them had things that were wide open. I mean, people had their VNC services, their desktops had no passwords. You could log on to their machine without a password, just by probing it and running.
Yeah, I mean, I will mention to the guys at ARDC, they should probably make that known. People need to pay attention to this stuff. What I do is I use NFT, which is the newest version of the Linux firewall rules, to allow incoming connections to port 44 only for a couple ports. And I typically use a non-standard port for SSH. Not for security reasons, just to minimize the amount of noise in the log, because there are a lot of scanners out there that are connecting to SSH servers and trying various passwords. The other thing I strongly, strongly advise is turning off password authentication. If you require a public key authentication, not only is it easier for you to use, but even if somebody guesses your password, they'll never know it. They'll never get in. So I strongly advise putting SSH on a non-standard port, but most importantly, turning on password authentication. If anybody has any, any needs any help configuring a system, I do this a lot, so just let me know. Oh, Paul, you're still here, right? I was speaking of the sites I manage. One of them is VY0ERC up in Ellesmere Island, and I was tuning around last night, and let's see, how do I share this here? Share. Um, yeah, saw this. That's not you, is it? I mean, Rob thinks it's somebody else's whisper transmitter at that site, but that looks kind of ratty to me.
It's nothing I've seen before. Wait a minute. Okay, I'm on. It doesn't look like me.
Yeah, yeah.
That's
What was
okay.
that
It's
other
40
one, Rob?
meters.
There is a ZACTech transmitter up
That,
there as well.
I
that's
mean, what
local. That's
do we?
local. Look at the signal strength. It's like
Well,
minus
yeah,
30.
yeah, sure, but
Yeah.
but still, how many dB down it is? It's only like 30 or some dB down. That's kind of, I don't know, not great, is it?
Well, it's not. It's a little. It's the ZACTech is a little. I wouldn't say toy. It's okay, but it's nothing like Paul's work at all in terms
Okay, it
of
doesn't have any
quality.
filtering on the output because it
Yeah.
sure doesn't look like it. Is it single band, just 40 meters?
It can do band scanning, but
Uh,
it depends on the model. I think these old ones are basically. I don't recall if you can do band scanning on them.
so we're talking about the signals that are kind of up in the green there, right? I
Well,
mean,
this is 40 meter ham
there's
band
that one
here.
peak.
That
I
that
mean,
is that's the intended signal, right? It's a
yeah.
70/40.
But are the others? Do we know they're actually associated with that
Yeah,
signal or
well,
not?
what it would run for 2 minutes and then go off, and I
Okay.
immediately assumed it was a local whisper beacon,
Okay.
and all that stuff disappeared. So,
All that other hash just wait, all of
yeah,
this or just the strong ones?
basically all of them. Well,
Wow.
I mean,
No,
there are other ham signals in there, obviously, but I mean, all this hash
all the
disappeared.
big stuff.
Yeah.
Yeah, I've never seen a whisper sound do that. So,
Okay, good. I just want to make sure.
Well,
it'd be worthwhile unplugging the whisper sound and see what happens. But
Yeah.
well,
um,
the fact that the waterfall lines have equal spacing is very telling. So,
Yeah.
I
I've
mean,
been thinking
that looks more like power supply issue,
it
like a
could
dirty
be.
power supply.
It could be. I think I did hear some hum on them. One thought occurred to me, is that I've gotten getting some ideas for tools or ways we might use our wideband HF receiver systems to basically inventory noise. In other words, since we can take a spectrum of the entire HF band, why not process it automatically, looking for all the distinct sources of noise? A switching power supply, well, usually you can't see its fundamental, but you're going to see some range of its harmonics that happen to be within the resonance of the antenna, or
Have you ever
something.
been to Dr. DeBoer's University of the Twente WebSDR and dig down into other weird things it does?
No. Does he do something like
Look
this?
through there. You'll get inspiration and probably say, "Wait, I can do that," because he does exactly
The
what you're
inspiration
talking
I
about.
have, is to do a modified version of a spectral plot and do a cepstrum analysis instead, and that should tell me what the fundamentals are for each of these switching power supplies. And so you basically look at all the low frequency peaks, and that will give you a list of all the different switching frequencies that are being seen as harmonics. And then you can easily tell, by turning something on and off to see whether one of those peaks goes away. So I think that's a very simple change to make.
Well, what you really need, though, and this is a project I've been working on, is well, related to it, is you kind of need a heat map because different sources produce different spectra, noise at different parts of the spectrum.
Well, sure.
So if you come up with like a 37 kilohertz interval, what you also need is a heat map of some sort over the spectrum to tell you where you should be looking for those, so you can most easily walk around to the receiver and track it down.
Well, my point though is that switching power supplies are generally going to have different frequencies, right? I mean, they're in the same range, but each one, and the harmonics from any given power supply are going to be exactly harmonically related. Right. So by doing this analysis, I should be able to give you a list of all the fundamental frequencies of each of the power supplies around you, regardless of where you actually are hearing them.
Right,
And
right.
then, it'll tell you, how many power supplies are generating the hash you're seeing. And then you could start turning things off and see if one of the fundamentals disappears. Do you know what a cepstrum is? A cepstrum is basically a spectrum of a spectrum. You
Right.
take a spectrum, actually what's it called, a periodogram, which is what I'm actually displaying. You take the FFT and you average, take the magnitude, throw away the phase, and you average it. That's called a periodogram. That's what a waterfall really is. And then imagine what would happen if you take a spectrum of that. If you get a series of repeated pulses, harmonics, that's going to be a period that is going to come out in the cepstrum analysis. The cepstrum was invented for speech processing. It's a way of determining the pitch of a speech sound when you can't necessarily hear the fundamental because it's below the high pass filter cutoff of the channel.
Yeah.
So it's heavily used in speech analysis for pitch extraction. And so it occurs to me, well, hey, I can use it to extract the pitch of a harmonic rich power supply.
I'm going from the point of view of once you know that, trying to find it, it'd be extremely helpful to know where those particular harmonics are strongest in the spectrum, so you can tune a receiver there and go, and be able to tell when it's come and gone. Because
But
right.
The point is that the cepstrum looks at the entire spectrum. If it's anywhere in the spectrum, it shows up as a comb, even in part of the spectrum. That will create a peak at that repetition, at that fundamental frequency in the cepstrum. And then you can just use that as an inventory of all the local noise sources you have. And if you find something and you think it might be a noise source, turn it off and see if one of those peaks goes away. Because otherwise, I'm often confused. I see, it's just a hash of obviously multiple sources, and it's like, I don't know where to begin. This might be a good way to do it. I don't know if anybody has done this. If anybody has, I mean, I'd be all ears. I've also
sounds pretty interesting. I mean, you end up with a catalog, inventory of what you found. And anyway, it's funny. I haven't heard that cepstrum for a long time. I used to work in audio.
It's an old idea.
Audio development, and the B&K equipment we had, for audio spectral analysis and all that, had those capabilities.
The word cepstrum comes from spectrum, kind of turned inside out.
Yeah.
I think it was developed, it was conceived back in the 60s, I think, when they started doing voice processing.
Yeah, that would make sense.
Standard analysis. Because I've already been studying it for use in automatic single sideband tuning. It's how you look at a sideband signal and figure out, are the harmonics properly located? There's only one carrier frequency where that will be true.
Yeah, no, that's great.
Right, but you can't assume, especially with male voice, low male voices and older radios with crystal filters, that you're going to get any of the fundamental. You're only going to get the harmonics. You might now, with good modern radios, you might now, but the beauty of the cepstrum is that it will tell you what the fundamental is, even if it's not there, just by the spacing of the harmonics. So it occurred to me that exact same method could be used to determine the fundamental of a switching power supply that's causing problems. So
but mistuned sideband voice, those harmonics will no longer be harmonically related.
Exactly.
But I guess you can figure that out. Okay.
Exactly. This has a long history. I found a master's thesis in a naval postgraduate school dated 1970 for somebody who'd come up with a way of making it easier for untrained people to tune single sideband. And it involved showing on a scope, on an XY scope, the envelope of the signal, the duck talk component on one axis, and then the baseband from the product detector on the other axis. And you get these spinning patterns that would stand still when you had the tuning right.
Yeah.
Okay, and when you think about it, the envelope detection is kind of like a cepstrum analysis. What you're getting is the beating between the spectral components in an envelope detector. So that is doing something like a crude cepstrum analysis, is telling you what the pitch frequency is. And then that controls one axis of the scope. And then if you've got the thing tuned properly, the patterns won't spin on the scope. They'll stand still, even as the pitch changes frequency.
That's why I love doing this stuff. There's so many cool
Yeah.
things going on.
So, when you make a receiver, it can handle hundreds of channels. I mean, everything has to be automated, right? I mean, I can automate FT8 and FT4 in a Whisper. That's easy enough. But how do I automate single sideband monitoring? This is something that contesters might like. If I could give them a K&IQ radio module with something that would just, or the expeditioners, just basically skim the whole section where you're listening for calls and just list everybody on a screen. That would be pretty cool for pileups, wouldn't it? I mean, I'm not a DXer or a contester, but it's kind of fun to come up with technology they might actually use.
Talking about speech recognition once you've tuned it in for call signs, are you?
Yeah, yeah.
Oh,
I mean, but you
okay.
first have to tune it in, right? Once you
Yeah.
tune it in, then you run into a speech recognizer, extract the call sign.
Okay.
The problem is there's no error correction. You got the same problem with CW skimmers. I want to play with a CW skimmer, see if they've gotten any better, but I expect that they make a lot of errors. And I hesitate to automatically feed stuff like that to PSK reporter unless I can do something to control the errors.
Yeah, I mean, there's redundancy. In contests, they may only identify once. And
Well,
if,
people calling,
dialect and accent may make recognition,
yeah. Well, people are
know,
calling, they're calling constantly. Very often they're using voice loops. So it's exactly the same audio each time.
yeah. So get it wrong exactly the same every
Same
time
time.
too.
Yeah. Actually, I was thinking about, doing combining, maximal ratio combining. I mean, that's with repetition coding. I mean, it's one way to do it. Although not every contester does this, but an awful lot do.
Hmm.
I mean, during the expeditions, I would hear people just sitting there calling, over and over and over again on their own spot, even though it's not considered good form. So if anybody has any experience with recent modern CW skimmers, let me know. I'm curious to see how they work now.
Well,
Also, hmm?
the one that everybody uses is the ancient and no longer supported one, the Efreet one, and that's the only one that everybody still uses. It was written to run under Windows 7.
Oh God.
Yes, yes, yeah. Unfortunately, it is also the one that works best.
Really?
Yes.
What does best mean?
Um, Most likely to produce if you twiddle the knobs right, most likely to produce reasonable spots, reasonably consistent. Let's see. Well, I'm struggling not to say least terrible, but that's actually more than you might think. The way they generally work is they require so many repetitions in a certain amount of time on a certain frequency.
The same call sign.
Correct.
And it has to be a valid call sign. I mean, you could look it up online.
Well, that doesn't work if you're getting into special event stations. So these actually, like most of them, the skimmers out there have these massive either call sign databases or this. I don't know how to describe it. It looks like something you might feed into a deranged regex to kind of validate all possible call signs.
Yeah.
I mean, I don't know who makes these things, but they're not really human readable. And I guess they kind of work. I mean, in Northern Utah, we run CW skimmers on all the HF bands, and 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 I guess they work okay. If I set them too low, the threshold too low, they'll generate a lot of bogus spots just from the random noise.
Yeah.
And like a classic example is on 6 meters, for example, we were there's some weak carriers because there's computers around and it's a radio, and we get consistent quote reports of the same call signs wherever there were weak carriers. Oddly enough,
Oh, okay. All right. Yeah.
Oddly enough, with a lot of E's and T's and M's, and and eyes in them.
Yeah, yeah, yeah. Surprise, surprise.
Right, go figure.
Yeah.
So, but
Yeah.
anyway,
Yeah, the problem is you wouldn't know whether it's a special event call sign or a fragment of a real call sign.
right. But the only thing you can do is just redundancy. Hopefully they call
Right.
CQ several times,
Right.
and also, and I think so unfortunately, this is closed source, so the secret sauce on what goes on behind is totally unknown. I mean, the guy stopped supporting this program in like 2014 and has absolutely no interest in revisiting it.
Yeah. Well, you can kind of guess. I mean, sometimes
Right.
just knowing that something is possible is all you really need to know to reproduce it.
Yeah, he claims, what is it? That's that statistical analysis tool that everybody was the big hotness about it 10 years ago.
Bayesian?
Yeah, Bayesian. There we go.
Bayesian analysis. Yeah, yeah, yeah.
Right,
And that's
right.
also, I mean, it's the basis of all error correction.
Right. Whatever that means.
Well,
But,
it is. I mean, especially linear low density parity check and turbo codes.
right. But his particular application of it is unknowable.
Mm.
But if you were to somehow spend the time and lose the hair to come up with something that would work equal or better, that was open source and would run on a variety of platforms, it'd be, and do so efficiently, it'd be great.
Yeah. I'm looking at your webpage now. You mentioned CW skimmer operations. Where can I see the results?
I'll go to KD7EFG on Reverse Beacon Network.
Okay, Reverse Beacon Network.
Right. All you'll get is, that's pretty much everything on Reverse Beacon Network is from a skimmer of some kind. I don't know if it actually reports which skimmers are used. There's a Ukrainian guy that actually has some kind of skimmer that I'm told it works okay, but he doesn't make it available. He doesn't make it easy to use for a general purpose public skimmer. Rather, it'd be something you would run at your station to look at, everything in the passband to see who's on the air, to see if you want to get that person, like during the contest.
Yeah. Okay, let's see. Spotter. KD7 EFG?
EFG. KD7 EFG.
Right.
So.
Okay, there we go. I see.
Right. But everything pretty much on Reverse Beacon Network comes from spots.
Okay, I see only CW spots. So they also, well, they have checkboxes for
Right.
PSK. Oh, they don't do FT8. Okay.
No, I supposedly it would, but the ones that people run most are PSK, less so nowadays, RIDI and CW.
Yeah.
We only run CW because, I mean, the code is so god awful. It doesn't matter whether you have a quad core machine or a 16 core machine. You can not get more than 8 instances to run. I don't know what it does. It does.
If you ran the virtual machines, you could, but
no, not even on a virtual machine. We've tried. God help us, we've tried. It thrashes. The code is so bad. It thrashes something that brings VMs to their knees.
Oh.
I don't know what it is.
Yeah. Well, I'm looking now. I do see spots,
Mm-hmm.
W1AW stroke 7. Who are they? I've seen W1AW stroke
Well,
something.
there's some sort of a ARRL event going on for the year, I guess.
Yeah.
And so you can reserve W1AW for your club or group or event for a certain time, a week or something. They've been doing it all year.
Stroke 7. I mean, that implies they're not using the station in Connecticut.
Correct. I think if you Google it, I'm sure you'll find a schedule of who gets it next. And you can hear several W1AWs on the air simultaneously with different suffixes.
I see a few beacons. That's a good idea. There are a lot of beacons on 10 meters. And so watching for those on known frequencies is a good idea.
Right. Yeah, there's some stats there, but they're to the nearest 100 hertz. But if you've ever listened to some of the 10-meter beacons, knowing it to the nearest 100 hertz is doing good.
Yeah, well, some of them are like obviously small self-contained boxes, and I mean, one of them had like really bad chirp. I reported that to the guy, and he fixed it like in a couple of days. And went and listened, and it's clean. So I mean, people do seem to want to get reports.
Right, yeah. I mean,
And many of these
yeah,
guys have been running these beacons for decades.
right. One of the things that CW Reverse Beacon Network is used for very heavily is for parks on the air, and maybe to the lesser extent, summits on the air. I've done it. I've done it personally. I'll put my spot in. I'll put in on the POTO website that I will be at a certain place, and in that time window, one of the things hears me. It'll post on the POTO website that here he is on this frequency, and suddenly,
Yeah.
like you call CQ, and in suddenly 3 minutes you're pounced upon. It's actually kind of cool.
Yeah.
But I don't have to do a thing. Other people probably spot me manually, but
Yeah.
for CW at least, it can automatically spot you if you tell
Yeah.
it beforehand that you're going to be
Yeah.
there.
It would be handy. I mean, I was recently following, some of those DXpeditions, and I would only see them easily if they were running FT8,
Right.
which many of them did.
Yeah,
But
box and
otherwise,
hound mode typically, yeah.
yeah.
Yeah, I mean,
Our network will pick them up on FTA very easily as soon as they get on, no matter where they are.
yeah, it's only been very recent that somebody actually wrote code where it would even be possible to get K9Q radio streams into the existing skimmer, the Afreet skimmer. It's a Canadian.
Yeah.
Oh, I don't remember. It's only been in the past year that code has become available. Because for
Yeah.
some reason, nobody's ever thought to write even something that would simply take, um, it's like a TCP stream or something like that.
How about this standard input on a command line
Nope,
program?
nope.
Yeah.
It's only been very
That's,
recent.
I keep asking for that, and it's surprising how difficult it is for people to give me that.
Right. Yeah.
The free DV people did give me they set up a whole package just for me so that I could do this. They're simplifying the build process, but it does work. I can pipe audio into it, and if there's a free DV signal there, it comes out.
Yeah, I mean, for northern Utah, we had to jump through hoops and pat our stomachs while rubbing our heads and stand upside down and horse turds to make anything work with IP audio streams. The skimmer comes in two flavors. I don't want to get out too far in the weeds, but I know. But you can get it so it runs individual instances, or you can get the skimmer server where there's like 8 bands in one instance. That's slightly less inefficient. But that one only recently has somebody written code to take the other streams, just take arbitrary streams in IP streams. But we've been running the individual instances, and it has to run under Windows, which is even another problem.
Yeah.
And what we have to do is we resample the streams on the web SDRs because we're using the same receivers, and we're using CSDR because it's just a command line and good enough. But then we have to use a program on Windows that will take the TCP stream and insert it into a Windows stream. And of course, if you've ever dealt with UIDs on Windows, it makes you want to kill yourself. Because they're hard to get.
Yeah.
They change randomly if you change the system around.
Yeah, I would never be willing to go to this much trouble. I would rather just write something from scratch.
Please do.
Yeah. Got enough ideas though.
Well, somebody else would.
Problem is some of them also take a lot of CPU time. You mentioned that one seems to. FreeDV takes, I don't know, 30, 40% of a core when it's just searching for a signal. So I'm not going to be able to afford too many of those. I can probably drop them on the main calling frequencies, but that's about it.
Yeah. We actually on some of the bands are looking like 10 meters. We're actually looking at 384 kilohertz of the band, or 190. Well, maybe 256. I think we run in 192 and a 96. So we cover everything up, through the beacon band from the bottom.
Yeah.
That takes a lot of processor time.
Yeah. I've been expanding my FT8 segments. I modified the FT8 lib that I've been using so that it understands can handle different sample rates in the WAV file header that I give it. So I can just change the sample rate and the bandwidth to anything I want, and it just works. And so as I discover new de-expedition segments for FT8, and they always seem to be new ones, I just keep making it wider and wider,
Hmm.
especially on 20 meters. But it still completes fairly quickly. I did try as an experiment searching for FT8 on every HF handband, all of them, and that was unworkable. That rolled over and died
I
quickly.
wonder,
So
I wonder
I
if
don't
there
know what
could
the
be,
limit
I
is.
wonder if there could be some sort of demon that just went around looking for blocks, and then when activity appeared there, it would just stay there for a while, and it might take it.
Well, a more clever way to do this is to have a signal classifier.
Well,
Have something scanning the band, looking for, okay, try to identify this signal. Is it CW? Is it RIDI? Is it
okay, yeah,
FT8? Whatever. And then put a decoder on it.
right, okay, yeah,
The guys in Australia track balloons do something like this because there's always different balloon manufacturers. Everyone has their own proprietary format, and they've got a decoder for each one. So they have something that does exactly this. They watch the spectrum. Actually, using my spectrum, they will simply watch for energy, and then they'll try to classify what it is. And once they identify it, they'll put a decoder on it.
okay,
And that seems to work pretty well for them. Actually, I owe them some fixes to the spectrum code at the moment. But they've been using my spectrum code for that for quite some time. All they really need to know is there's energy, because in the 400 megahertz band, it's just noise, either noise or a radio sound signal. Problem with ham bands is if you give it a signal it's not looking for. I think that was my problem trying to decode FT8 and then sideband segment, is that it goes nuts trying to find an FT8 signal in sideband. If it's just thermal noise, it ignores it. It doesn't
right,
take a whole lot of, because I think it first does a fine spectral analysis looking for bins that have energy in them. Then it starts looking at those more closely. So if it's just noise, it won't actually cost much,
okay,
which means it should be possible to scan large parts of 10 meters without too much trouble, because it's usually noise.
right,
But 40 meters at night is a different story.
yeah. 10 meters is either noise or dielectric welders.
Oh, I don't think I've
Yeah.
heard those.
Oh well, if you've probably noticed these little crescent shaped swoops across 10 meters on waterfalls. It's
Oh,
yeah, they're uh, so around this time of day, or when 10 meters might be open to Asia, you notice some of them have 50 hertz components on them,
uh,
which kind of rules out them being
North
daytime.
America.
In the
Yeah.
middle of the daytime, though, when 10 meters open, you'll see them here, and they're all 60 hertz, and
Huh.
they're supposed to be on the ISM frequency within a few kilohertz, or it's somewhere around the CB frequencies.
Yeah, it is CB.
But they can be anywhere from 24 to 33 meg. They're just
Mm.
they're free running. There shouldn't be, but just cheap Chinese ones that they probably put an FCC sticker on them, because those are cheap to print, right?
Are there any ISM bands below 100 kilohertz? An LF or VLF?
Not LSM, not ISM specifically.
It would be nice, because if you could park switching power supplies there, the problem is, they all free run, so
Yeah, I mean,
it'd
would
be
they?
difficult to keep them there. What?
If they should, would they? Yeah,
Yeah. Well, you can write the rules to say that, if it's too difficult for you to shield it, which is certainly preferred, then you're required to park it here. The problem is not the base, it's the harmonics is the problem. So
right. And if switching power supplies were not only stable but absolutely pure, then there might be some hope that.
yeah, they're not. Well, that's the other thing I've been thinking about, because the harmonics are, regular, predictable. I mean, you know what they look like on a waterfall. I'm wondering if I can make a filter that would dynamically notch them out.
Well, I mean, we were talking about this before. You
I
could,
think we did. I think we did.
right,
Yeah.
right. I mean, you have like several 10 examples, so you could probably convolve them out, or whatever the hell the term would be. In theory, I mean, because every other one's probably almost identical. In
Yeah,
amplitude.
exactly.
Yeah,
Exactly. Right.
right. So I mean, in theory, you should be able to make them mostly go away.
Yeah. I know I can extract the fundamental. I mean, I'm confident that I can do that, knowing how a substrum works. You
Right,
just
right.
you take a periodigram that is an ordinary waterfall display, and then you run that through an FFT. You even take the log of the a log periodic. It's just like you would display it on a waterfall. It's almost always logarithmic.
So,
Then
so
you
this,
run that through an FFT, and if you've got a comb, it will find the period of that comb, which is the spacing between which is the
so,
fundamental
so,
frequency.
so, solar being one of the banes of Ham's existence, the Enphase runs spread spectrum clocking on their power converters.
If they didn't do that, if it was just one tone, it'd be easier to notch out.
Well, they
Yeah,
did.
right.
They used to not do that, and I can tell you, having been over that Ham's house, it was an effing nightmare. I mean, you just tune it, you just tune up and down the bands. You just hear constant tones everywhere. But anyway,
Mm.
but, and the general gist is if you have an N-phase solar system, you definitely know it. If your neighbor has one, you might know it because
Yeah,
all you see is a raise in the noise floor. But if you switch to AM, of course, you can hear a hum in
it
the
both.
background. It's
Yeah.
gains modulated to a degree, amplitude modulated. Would your system actually be able to divine that as well?
Uh,
I
Not
mean,
sure what you mean.
separately from everything else that has 60 hertz on it.
Well, it'll identify the fundamental frequency. So the idea, what I'm trying to do is I'm just trying to say, okay, how many of these things are
Okay,
there?
yeah.
And so that I can then go around and start turning things off and on while watching to see whether that particular fundamental goes away. It's just a way of separating and first inventory how many interferers do I actually have?
Right.
And without having to tune over the bands, because some you might only hear, in the high frequencies, some may only hear in the low frequencies, depending on whatever's resonating. But if you do a cepstrum of the entire spectrum, then you should be able to find the fundamental no matter what it is. And the fundamental is always going to be low. I mean, what power, I mean, power supplies, at least computer type power supplies seem to, let's see, about 65 kilohertz, 70 kilohertz seems to be a popular frequency. What other frequencies are used?
The bigger the power supply, the
The
lower
lower the frequency.
the. But yeah, I mean, my observation is if you constrain it between like 30 and 90, you get almost everything that's free running.
Yeah. Are there any that actually run in an HF? I mean, because I got some strong spurs in 80 meters from some access points that are
The
probably DC-DC converters. Are
Yeah,
there?
point of load supplies on a circuit board will. The other one that does that are PoE. Some of the
It is
PoE
PoE.
ones,
Yeah, it is PoE.
right? And those are almost impossible to
But
kill.
they switch in 80 meters.
I don't know about 80, but they're in the megahertz range, so they.
Okay.
But the thing is, ones I've seen usually aren't too bad in radiating because typically they're tiny and use pretty good. Even the cheap ones use half decent, low ESR, chip caps.
I think it's common mode down the cable from what I've seen and getting re-radiated on the other cables coming out of the switch.
Right. Yeah.
You
I
know, you
yeah.
can, you can start throwing cores everywhere, ferrites everywhere, but that numbers never really seems to give you. I mean, you might help it a little, but it never seems to be
Yeah.
a real solution.
Ferrite alone, my experience in testing has been that you're lucky to get 20 dB.
Yeah,
I mean,
exactly.
well, which is great if it's only S4 to
Yeah.
begin with.
Yeah. I mean, one of the noise sources I'm starting to notice, and I know this is going to show up in my results, is about 61 kilohertz, which is the 125 megahertz clock rate of Ethernet divided by 2048.
Hmm.
And I see that one a lot. I'm seeing that one at KFS a lot.
61 kilohertz.
It's around 61 kilohertz. Take 125 megahertz,
Okay.
125 exactly, and then divide by 2048. It's 61.03515,625 kilohertz. And I am seeing, once you know to look for that one, I start seeing combs everywhere now because where there's an SDR, there's an Ethernet. So I was seeing it a lot at KFS. I see it at home, mostly on the higher bands. The lower bands, it usually gets covered up by noise, but on the higher, once you get up to about 20 meters or higher, it starts to become rather prominent.
Hmm.
You know, these things are, it's the death of a thousand cuts. You know, if it was just a couple, you could tolerate them, but the more you have, it's just really wears you down. It's like HF is almost becoming unusable some places.
Well, that's why we have a WebSDR, unfortunately.
Yeah, well, but unfortunately, WebSDR has a computer in it, so
Right. I mean, yeah, we jump through hoops to keep things out of it.
yeah. The QESDR gives you the option of running the Ethernet at 10 megabits, and that will not have the 61 kilohertz spur.
Right.
This 10 megabit Ethernet 10 base T is Manchester encoded at 10. In other words, it's put on a 10 megahertz carrier. So we will get in the WWV though. Though, you know, everybody likes 10 megahertz for some reason.
Right.
Why did WWV have the transmit there? Probably seemed like a good idea at the time.
I mean, there's always CHU, and the old days there was VNG as well.
Well, there's RWM. I listened to
Oh
RWM
yeah.
last night by way of VY0ERC. They were quite strong.
Oh, that's
And I
true.
wasn't that familiar with the format, so I began listening, and I noticed that the UTC UT1 offset is now 0.04 because they transmit it to like 0.02 second accuracy. WWV only does it to 0.1.
Hmm.
Same with CHU, but it's been close to zero for a long time. I hope they get smart and abolish leap seconds before we need another one.
Everybody on Earth needs to stamp their foot in the right place to keep it from
Well, global warming is starting to have measurable changes now.
Hmm.
Expansion of the oceans, melting glaciers, redistributing the mass of the oceans, the atmosphere, and changing the moment of inertia, of the Earth. But if we ever have a negative leap second, which is possible, oh my God, can you imagine how many things are going to break?
Has that never happened in recorded history?
No, there's never been a negative leap second. Leap seconds were started in I remember what happened, 1972. They got rid of a much even worse system where they were like making 100 millisecond step adjustments every few months and even changing the rate of the second, believe it or not.
Hmm.
They would offset that. That was unworkable. So they went to this leap second thing. I think it was December 1972, I think. I remember I was the new ham at the time. And it probably seemed one of these ideas that seemed like a good idea at the time, but with computers, leap seconds are a pain in the butt, especially because nobody knows how to handle them properly.
A friend of mine used to work in the financial trading industry, and in the software he wrote had to take into account the precise time going back decades in every major city on the planet. And he said
Yeah.
the most difficult one to deal with was various cities in Saudi Arabia.
Oh, they use solar time, don't they?
Right, right. Midnight was when the sun went down, and I don't know, is it when you can't tell a black thread from a white thread? And it changes every day or
Yeah.
very frequently. And so most of the files for the cities around the world were like a few kilobytes, but those were hundreds and hundreds of kilobytes.
Yeah. I know Jews have rules for like when the Sabbath begins, but I don't think it affects the date. It just, affects when they have to be observant. So that wouldn't be the same thing.
Right.
Um, I actually years ago wrote routines to convert time and handle UTC throughout the 1960s. That's how I knew about all this stuff. I don't know why I did. I think I had ideas of going back to old Apollo orbital elements and trying to see if we predict where the lunar modules are now, the ones that are still up there in orbit.
Hmm.
Um, if I had this idea that if you knew the orbit precisely enough from tracking, you might actually be able to project it forward.
Hmm.
But I got as far as doing all the timing stuff, and I didn't do anything else. But time is a mess. I do recommend people run either Cronny or NTPD on other Linux machines. Don't use the NTP client that's built into systemd. It's kind of half-assed. It doesn't take into account leap seconds. If you do run one of the two recommended ones, then my code will see it and take and use it because I use GPS time internally. I wanted to make sure that all my timestamp, none of it would ever be affected by leap seconds. But then where do I get that time? I get it from the UTC clock. So unless I know what the offset is, I'm going to come up with the wrong GPS time.
But it's one thing I've never done is look at, statistically look at all the DTs on FT8 or Whisper around the leap second time to see how long it takes for everything to go back to zero-ish.
Has there ever been a leap second during FT8's time?
Let's
Maybe.
see here. It might be true. I think it's what was the last leap second, like 2014
I think
maybe?
it was 2016. Let's see, leap second. When was the last leap second?
Let's see. 2016.
2016. Yeah, that was the last one.
2015 and
At
16.
the end of 2016. Yeah, at the end of 2016, we had one.
Right.
So we never had one the whole Trump era. Yeah, well.
I don't know.
Yeah.
I don't know when FT8 appeared on the scene. It's somewhere close to that, though, I think.
Let's see, when did FT8? Released on June 29th in 2017. So no, there has never
Oh,
been a leap second in the entire existence of
but Whisper there. What
FT8.
Whisper's been around for several.
Yeah, Whisper is not as well. I guess it still has to be timed, but that
Right.
would be interesting. But then that's the whole reason to try to avoid leap seconds is so you don't have all these artifacts coming out. So let's see, what is the DUT1 now? Dailies are IERS both in A. Okay, here we go. All right, found it. The International Earth Rotation Service. I love that title. I don't think that's their official name anymore, but the International Earth Rotation Service.
The ones that put oil on the spindles, right? I don't know.
Where they take requests, you can imagine Joshua asking him to stop the Earth's rotation for 2 hours.
Right.
Bible story, remember that?
Right. And then the crust of the Earth ripping off the mantle.
Rips off and we all go flying into space, yeah, from the
Right.
inertia, right?
I think there was an XKCD along those lines years ago.
Oh, XKCD is great when he does these what if things, and he thinks of
Yes.
all these things that you wouldn't have thought about, but make sense when he points them out.
Right. Yeah.
Okay, this is the polar position. Okay, they got these observations. Oh, here we go. UT1 minus UTC error. So for 9, I guess, is the most recent one they've got. The difference was 0.047697 seconds. Okay, that makes sense because RWM transmits not just tenths of a second, they also have a second field where they transmit 200ths of a second, 0.02 seconds, and there were 2 ticks that I heard. So that must mean there were the difference is 0.04 seconds, and that's exactly what it is. It's actually almost 0.05, but they only do it to 0.02 resolution. So WWV will have to change its format if they get rid of leap seconds. They handle the offset growing to more than 1 second, but they can solve that problem.
Doesn't WWV's PSK have like two sets of codes that it transmits? One that's every minute and one that's has a period of much,
There's
much longer than that.
there's no I don't think there's any PSK on WWV. There is on WWVB.
Oh, sorry, B. I meant
Yeah.
B. Right.
And
Yeah.
also DCF 77 in Germany. I think they were the first to do it. Put
Yeah.
it
Also the French one as well.
They still have one. They put that on a low frequency broadcast station, as I recall.
Yeah, France one or whatever it was. Well, their program audio went away and they lowered the power, but it runs I don't several
TDF.
degree.
Is TDF something?
Yeah, that's just I
Oh,
think
the
it is.
Télévision de France, I believe
Yeah,
it's.
that's the one.
Yeah.
I think it is TDF.
Um,
I'm just looking at the
I'm looking up their TDF group. Okay. Officially renamed TDF 2004 French company. All right. Oh, they're big. They have a lot of DRM broadcasts, but I'm never able to decode them. DRM is, I think we talked about this before. DRM has been a big disappointment. I can almost never get signals good enough to decode.
right.
The one that does come in strong enough consistently every night is North Korea on 6140.
Really?
But I can never decode them. They're using some non-standard application code that won't decode in a QESDR.
Huh.
So even when the signal-noise ratio is high and it's got a nice constellation, I can't decode it. It stays red.
Yeah, yeah. Well, what is it? Let's see. Voice of Career. Yeah.
Career, yeah.
Yes.
Yeah, I love that. I love that North Korean English that accent when they speak English is very distinctive.
Yeah, they're back in the 80s. They were on the obvious frequency of like 9977 kilohertz. Probably because that's where they had a crystal. I don't know. But the thing I remember was they had a male announcer who sounded for all the world like you'd expect Elmer Fudd with a Korean accent to sound like. Right. Let's see. I haven't, yeah, none of the Kiwis at Utah have DRM enabled at the moment.
Yeah, I've been kind of disappointed in that because it was, sometimes I've been trying to get some of these and there are web SDRs that have it disabled, but I understand why because it's a real CPU pig. It barely
Oh,
runs.
right, and it won't run at all if you. I think if you have a 4-channel one, you can maybe one or two instances of
Just
DRM.
one, and you're not, and nobody else is allowed to run any extensions. So,
Right.
and your waterfall noticeably slows down while it's acquiring. It's obviously
Right. Yeah, at least with the Bigabone Green.
Yeah, I mean that box really needs a hardware upgrade. It's a nice piece of software, but the hardware is just really underpowered.
Right.
Here we go. It's ALS 162. French time signal transmitted a long wave carrier frequency 162 kilohertz from Toulouse, France.
Right. Yeah, that's the if you go to the University of Twente Web SDR, there's a note on that frequency saying that you can actually hear the Luxembourg effect on the carrier. I don't know if you can so much now because the long wave broadcast stations are gradually dropping out of existence.
Yeah, they're probably very expensive to run because they might have to run very high power.
I think Droitwich, Romania, and Poland and Algeria are the main ones that are still running. But
On LF.
correct. Yeah.
Okay, it uses phase modulation plus or minus plus or minus 1 radian in 0.1 seconds. I guess it did that so it would be compatible with AM broadcast signal, right?
Right. I guess.
Yeah,
Oh,
because an envelope detector would not notice that.
right, right. Although they haven't run audio programs on that transmitter for a
Yeah,
decade
since
or
it
more now.
says 10 years, it says until 2016. It was formerly broadcast along with the France Inter-Radio program until 2016.
Right,
Now operates independently, specializing solely as a time signal. Runs 800 kilowatts, covers a large portion of France. You think for 800 kilowatts, you cover the whole country.
right.
And apparently it is used for synchronizing public clocks, so they actually use it. I don't know what the Swiss use. You know, the Swiss have their famous railway clocks that all get synchronized somehow.
They originally had their own on 75 kilohertz, but they shut that down about a decade as well.
They're using the German one.
I believe so. Yeah, yeah. I think they
Because
just
that's the other one. Yeah, the
BCF
DCF
77.
77. Yeah.
Right, 77 and a half. Yeah, yeah. That. Yeah, yeah. I think they switched to that. I don't remember. HBG, I think, was the call sign of the 75 kilohertz Swiss one.
Hmm. Oh, French station, it's changed frequencies a few times. In 1977, they added the phase modulated time signal. The frequency had been 164 kilohertz. They changed it to 163.84, which is the fifth harmonic of 32,768.
Right.
In 1980, they installed the first atomic clock to regulate the carrier. On 1 February 1986, it was changed to its current value of 162 to bring it to a multiple of 9 kilohertz in accordance with the Geneva frequency plan. Yeah, some parts of the world use 9 kilohertz spacings for broadcast for medium wave also.
Most
Uh,
most of the world does.
oh, the power has been as high as two megawatts.
Yes.
Formerly 1 meg, increased to 2 meg in 1981, reduced to 1.5 meg in 2011, 1,100 kilowatts in 2017, and subsequent to 800 kilowatts in February 2020 for cost savings.
Yeah, I guess if you're only sending PSK,
Yeah, if you're not,
I,
well, it
I
was reduced in 2017. That's when they stopped running an audio program.
wonder if they wonder what the cheap electronics are doing to detect that phase shift king. I wonder if they're just running like a equivalent of a discriminator and looking at the just the wobbling around DC.
Well, a classic way to detect PSK is a delay line in the multiplier,
Right.
a non-coherent way, and that's a cheap way to do it. That's probably what they do.
I guess so. Yeah. I mean, practically speaking, you could probably just have a high Q coil tuned there and just a plain discriminator, get something useful out of it
Yeah.
if there wasn't if they could avoid a DC bias.
Binary encoding is identical to that of DCF 77, but there are some extensions.
Let's see here. I didn't. Okay, I hadn't realized that there was still a Russian long wave trans signal. I thought that was gone years ago.
Is it RWN?
RBU.
Oh, RBU.
Yeah, 10 kilowatt on
That's probably really
66
hard to get.
on 66 and
6
2/3
and two
kilohertz.
thirds. I love it. Yeah. 66 and 2/3.
Yeah, back in the day, I mean, there's a whole bunch of them. I believe Czechoslovakia had something on 50 kilohertz, as did Russia.
Yeah.
Soviet
Yeah, there
Union.
used to be more of them. The Brits still have MSF on 60 kilohertz.
Which does a pretty good job of clobbering
Yes,
WWB clocks in the East.
on the East Coast. Yes, yes, I've heard that. I mean, it'd be nice if they were like make their standards, to make their formats the same, then would actually be beneficial.
Well, and JJY, of course, has a 40 and a 60.
Yeah, that seems strange. That's right. JJY used to be on HF, but they stopped that a long time ago.
Correct. But more relatively recently is BPC in China. When did that go on the air? 2020, 2002. They put that on the air.
BPC?
Yeah, on 68 and a half.
Okay. I
Now
didn't
they
know
have,
about them. I know BPM. I hear them all the time on HF.
yeah,
68.5, yeah. 90 kilowatt for 20 hours per day with a 4-hour break. Um, well, 90 kilowatts, that's healthy. I mean, it's more than WWVB.
I'm presuming they mean ERP rather than
Well,
power.
I don't know. I don't know. I
Yeah,
mean,
that it's vague. I mean,
yeah. Yeah, at those frequencies, the distinction matters.
yeah, on 630 and 2200 meters, the convention on your whisper signal and whatnot is to put your estimated ERP rather than actually how much power you're running. But you always can
Yeah.
tell people that don't do that.
Yeah. Although I don't know how accurate those estimates are. I mean, you've got to figure out what, well, the radiation resistance is probably not hard to compute, but then figuring out what all your real resistances are.
Right,
I
right.
guess they could be measured, I guess.
Well, if you have a selective voltmeter and a calibrated antenna and do it at radials, just like broadcast stations do, you could probably get a pretty good estimate. I
Well,
mean,
they usually rely on field strength measurements.
exactly.
But they'll hire an outside consultant to do that for them.
Right, right. You could do if you did all that. There's some hams who've done that. There's a guy in Ward. Name is let's see, Ward. He runs an antenna company out of Arizona. He actually had gone through the trouble of that, and it was convenient when he was transmitting because you know that he's probably as close to being the real ERP as anybody could practically be.
Yeah.
And I was comparing my signal levels with his signal levels across the country, and 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 either he was optimistic or I was or pessimistic, because but anyway, but I would be like 10, 15 dB below him.
I just posted a link to a page that seems to have a summary of current low frequency time signals.
Oops.
Isn't it funny? JJY transmits from 40 kilohertz and 60 kilohertz, and they have 50 hertz power and 60 hertz power. They can never seem to, get that country unified on frequency standards.
Yeah, the north is 50 and the south is 60.
That's right.
It's the
And it's because
Siemens side versus the Westinghouse side.
Westinghouse side, right? They apparently grew independently, and they butted up until they butted up against each other, and already they had enough installed that, they didn't want to change anything. Just like railroads still use weird frequencies.
It wasn't until the 40s that all of U.S., continental U.S., uh, except for Niagara area, was 60 hertz.
Yeah, I didn't know that for a long time.
And then the 25 hertz at Niagara only went away a decade or so ago.
But it's still present in Amtrak.
Well, that's true too. Yeah, they probably
Yeah.
have. Yeah,
Amtrak has to make its own.
right, right. And it was all about a decade or so ago that Con Ed stopped delivering DC for across town.
Delivering DC seems easy enough.
Well, but that was they would run DC cables miles down the street to buildings, and all
Yeah.
it was ever used for was elevators. And eventually,
Yes.
you get your own damn rectifier, please.
Right, exactly. Yeah.
Right. Yeah.
It's like buying your own cable modem.
Yeah.
Okay. Some of these are historical. Prague had one, but that went off in 1995. RTZ.
Oh, that one didn't show up.
RTZ 50 kilohertz, 10 kilowatts in Irkutsk. MSF, of course.
Okay.
WWVB, RBU. Okay, that's in Moscow. HBG shut down in 2012.
Right.
It was DCF 77 compatible.
Okay. Okay.
And then DCF 77.
Yeah.
Germans probably has some agreements with surrounding countries to keep it on the air.
Right. I don't know if they use it for. I don't know. Do they? I wonder if they use DCF 77 for the. I don't think they use it for teleswitch stuff.
I think they do. Now that you mention it, I know at least one of you, or maybe it's the French station, but I do know that some
Well,
of them are used for
yeah, I think
things other than time.
yeah, I think the French one does use, but there's some. But if you go to some of the European web SDRs, you see some CW carriers right around the 2200 band that are FSK carriers. They're
Yeah.
lockstep with each other, and those are like I don't know, DCF 135 or whatever the hell it is. In fact,
The Germans have more than one?
yeah, apparently they have multiple ones.
No,
Just
they don't mention on this list.
let's see here, but they probably wouldn't show up there. Oh, there it is. DCF 39 and let's see here, DCF 4939 and DDH 47. They're
Oh.
they're used for their version of Teleswitch, and I
Oh,
get
they're not used for time. They're used for teleswitching.
correct.
I got it.
They
Okay.
probably
That's what I must have been thinking of.
right. They probably convey time, but
Yeah. BPC, it says here it's commercial and it's proprietary format and you require a license for the receiver. Well, that's a challenge.
well, I think some of it is known, but I think well, if you go to the if you go to the if you go to the Wikipedia page, they have the public format, which is kind of similar to what WWVB does.
Yeah.
But apparently they might have something else that's there as well.
Oh, your people recorded leap seconds. Some people can really get into this. Well, that reminds me, FMT is coming up in a couple days, isn't it?
Oh, that's
Frequency measurement test. I want to try
probably
that.
it's probably on Thursday if it wasn't already on there.
Huh. I typed FMT into Google and it came back with fecal microbiota transplant.
Okay.
Okay. Maybe I should have been more specific.
Let's see
ARL.
here. April 20th. So what?
Um,
No, that's when they're due.
April, yeah, it's April 17th. So yeah,
Right.
5 days.
Okay, yeah.
0230 Zulu to 0320 Zulu.
Right.
Uh,
Maybe I'll try to forget that one.
First on 40 and then on 80 meters.
Connie and don't know who the
Well, I don't really have to do much. I mean, just make sure my stuff is working and do IQ recordings of all these frequencies plus IQ recordings of all the WWV frequencies at the same time.
mhm.
And then post-process them. And I have 3 days to post-process them. Yeah, the only way to get in the green box is to make a good guess about what the ionosphere is doing.
Right. I've been in the green box. I have been in the green box for all the frequencies on more than one occasion, I believe. But before they had it, I think the green box part is actually quite new. I think it just used to be not green.
Oh, they already had the results page up for this FMT, except that it's empty.
I would hope so. Although these days, people reviewing a movie before and telling how bad it is before it ever comes out.
Yeah. Okay, so they're twice a year. The last one was November 7th of 2025. There's a lot of people in the green box. Are
And
you in here?
they used to do more bands, like 10, 15 years ago. 20 meters they used to do.
Uh,
And that was actually
N5 TNL made and N5 TNL's in the green box. Congratulations, Scott, if you're still here.
Yeah, I've been there.
Yeah. Yeah, I think you that's right. I looked at this. You mentioned that you were using KNIQ radio as your base.
Yes.
Um,
and 7QXB's in there. He's a guy, yeah, kind of local friends of mine. I kind of got into that. It just they ended up with Z boxes and I recognize a
there we
couple
go.
of
Let's see what Scott would he do? RX 888, KNIQ radio, PCM record, SDR console, DMOD, FL digital measure. Yeah, that's reasonable. Wildly guessing at Doppler corrections. It measured CHU at 7849.999.2721 WWV at 49999.748.
What I really ought to
All
do,
low, yeah.
what I really ought to do is, in addition to doing it the normal way, enter submission, say under the club call sign of Utah SDR, using a Zenith transoceanic, along with outboard signal generator, just see if anybody notices. Because an AM only one would be fine. AM receiver would be fine.
Yeah.
I was just trying to think of one of the worst receivers out there for ham use. One of them that comes close would be the what's that Hallicraft one that was ubiquitous. SX20? No.
I don't remember. Been too long.
Yeah, it's essentially an all-American 5 where it covers shortwave.
I wonder how accurate these transmitter frequencies are actually known. I mean, they're specifying to 10 millihertz, which implies an integration time of almost 2 minutes.
I think Connie has mentioned in the past that he has an HP signal generator that's GPS locked with a Z box.
Hopefully, he doesn't have a old Leo Bodnar with a frequency offset.
Well, I mean, what off by 4 parts per trillion
or something. Yeah.
Well, who would know, right?
I mean, HF, maybe nobody would know.
Definitely no. Well, not in a 2-minute transmission.
Actually, come to think of it, I've probably got one, so I don't know what corrections I should make.
Yeah, I actually have parts kind of on order to make a frequency tripler for Northern Utah to lock the 888s up there to the third harmonic of the 10 meg output. We're already running at 30 meg, but I think Scott checked it and determined that.
Oh, it will run on a 30 megahertz clock?
Oh, it's fine. Yes.
It'll run
on the 880 will run on 5 megahertz clock or.
Oh, I guess that's right. It will. Yeah. You just have to tell it what it is. That's right. I do support. You can specify.
Yeah, we did that. Yeah, but yeah, we're going to deprecate the Bodnar for the time being. We already have a GPS DO on site, so that does prompt holdovers.
Sure.
So why not?
Sure. Okay, I got to do this. Because I really should have everything I need. I mean, assuming my loop is good enough to hear them. And I mean, last time I listened, I did hear them. I'll probably end up writing some ad hoc software after the fact.
Yeah, Clint, KD7EFG, I measured it at about 16 parts per trillion.
Oh no. Chicken Little.
That was comparing your other GPS DO from the Clicky box.
Oh, is that that's the Bodnar offset?
Yeah. The AAA is clocked by the Bodnar, and I used your PLL and Radio D on 25, 2.5, and 10.
Yeah.
No, 25, 2.5, and 10 was at WWE2. And it was 13.5 parts per trillion. KD7EFG was 16 parts per trillion.
Trillion. Okay.
Yeah. You want to check me? Here's the numbers. I just found them. At 24.92685 megahertz, 14,011 degrees accumulated in 97,200 seconds. I'm not sure I did the math right.
Okay. Did you use my built-in calculator? I mean, it's in control.
No, because I wasn't sure that it would stay locked. So
that's just it. Yeah, if you slip, you're lost. So it would probably work for the station at WWV, but it wouldn't work anywhere else. I wouldn't rely on it.
So I logged once a second so I could plot it.
Yeah. Yeah, the problem is those fades are usually 180-degree phase reversals, which POLs are not good at tracking. Another idea on the back burner is to make a
Wait,
POL
what?
that understands this.
What did I do wrong there? Where would I see the 180?
No. What I'm saying is that whenever you have a fade on HF, you have a phase flip.
Oh, okay. Okay.
Yeah. So what that says is that a POL ought to know that, right? Instead of having to find, if you've got a really narrow loop filter, it will take a while to relock when the signal comes out of the
Yes.
fade, even if the fade is only instantaneous.
Well, it sounds like you almost need to have two loops running in case. I mean, it's not always the phase flip, or I guess, but I mean, it probably usually is.
Well, when you go through zero, when you go quickly through zero, what mechanisms could cause that other than two components that are exactly canceling? How else going to happen?
Right. It'd be interesting. Well, I mean, right, but I mean, it could. I mean, the other thing that could happen is it could go down like 20 dB without doing a phase flip
Oh
and
yeah,
effectively
yeah,
disappear from your
that's true.
right. And it'd be interesting to do it'd be interesting to track that on WWV, say.
What you could do is the loop could actually, hypothesize both, right?
Right,
0 and
exactly.
180, and then switch from one to the other over some period of time if it appears that the phase has in fact inverted, instead of allowing the loop to do it, depending on how narrow the loop is.
Right.
I usually run about loops bandwidths of like a hertz or so is usually good enough. Later versions actually will automatically knock the loop bandwidth down by a factor of 10 when you lock, which is something I was always doing anyway.
One thing I've toyed with the idea of, but never done on the FMT was in a Spectrum lab. I could effectively run it through a squaring device and then measure the second harmonic, and which would get rid of the phase
Yeah.
slip.
Yeah, you can do that, but it's more sensitive to noise.
Right. But on the
Yeah.
FMT, usually you're not fighting SNR, especially if you're down in the, your bin width is that small.
That's true. That's true.
Right.
Yeah, if you're
Yeah.
gonna have any hope of this, you got to have a signal that's not too weak.
Right.
It may fade, but it's the average SNR should not be too low.
Yeah, I've done that trick before too. Just run everything through squaring to get a better
Yeah.
mix.
I mean, that's the standard way you demodulate QPSK or well, BPSK, with QPSK you do it twice
Oh
so
yeah.
that there could be a 90-degree ambiguity.
Yep.
I kind of wish I prepared for Artemis when because I was watching the signals through Bochum most nights when they were tracking.
What did they
Hmm?
mostly use?
Well, I know what they use because Dan Estevez, what's his Spanish call sign?
I mean,
Anyway,
did they?
he did it for Artemis 1
Okay.
back when nobody else was paying attention because it wasn't a crew on board, and he wrote all this stuff up. And the lower layers were all CCSDS standards. The problem is that the application layer data is encrypted.
Right.
Now, NASA was they were soliciting help from anybody who had a dish who wanted to help NASA for free, demonstrate a tracking capability. And it seems to me that if they want to, if they expect people to work for free, then they got to give them something other than bragging rights. And that something ought to be, a voice channel in the clear most of the time. They can always reserve the right to encrypt for a medical conference or something, but it ought to be clear since
Right.
they're broadcasting it anyway. Same with the video. But that would be cool, actually get that yourself. But he actually found many of the channels were unused, but that was a test flight with no crew, so they probably didn't have as much need for a downlink. Somebody, I think it was Peter DB2OS who runs the site of Bochum. I asked what the EIRP was, and they said that was under NDA. He implied he knew it, probably under NDA from NASA, and that just seems idiotic to me. I mean, why would you want to keep an EIRP confidential. That's
Oh,
ridiculous.
from the capsule.
Yeah, down like to the ground. I mean, well, the frequency, the DSN now site is a lot less useful than it used to be. I mean, it used to give exact frequencies with Doppler, and it would give exact signal level strengths. And now they only tell you the band that they're on, no frequency at all. And the signal strengths are often like the nearest 10 dB, which is kind of worthless.
Hmm.
Some middle manager somewhere must have gotten nervous. But it wasn't like they could keep the frequency hidden for long. It was 2216.5. Everything was S-band. But the data rates ranged from about 1 megabit to 6 megabits. And it didn't always have to do with distance. I noticed that when they first acquired on a new ground station, it was usually at 1 megabit or maybe two with a strong carrier. And then after a while, they would go to a higher data rate and drop the carrier.
Are they just using more or less standard like QPSK or something?
I'm pretty sure it's offset keyed QPSK.
Okay.
I'm pretty sure it's QPSK because the spectrum was not exactly symmetric.
Oh.
If it's BPSK, the spectrum should be symmetric around the center.
Mm-hmm.
And you saw a complex structure in the spectrum that did not change very often. It was being averaged, but it also just was kind of fixed. So I suspect that they were sending a lot of repeating patterns, probably empty channels that were being scrambled.
Well, I mean, how are they conveying their ranging data?
Well, ranging is done. Well, the main tracking job is Doppler, right? You just acquire the carrier, and if the transponder is a synthesizer that phase locks to a rational multiple of the uplink frequency as received.
Right.
So you can see them usually when there's an acquisition, the frequency will jump because it goes from free running to whatever the ratio is times the received uplink frequency. You'll see that when they acquire a spacecraft that is transmitting all the time, but it's only being tracked part of the time. Here, I'm sure they were being tracked all the time.
Yeah, well, I believe what Apollo, sort of
It's the
in the
same method.
noise. Yeah, in the noise, they ran just a pseudo random sequence under everything.
Yeah, that was a ranging signal and I don't know what if they do here. They probably do something similar.
So they were running mostly S-band, at least when they were.
It's entirely S-band from what I could tell. There supposedly were some tests of the optical link, but I never saw anything.
Okay.
Optical, they could run up to a couple hundred megabits. But I don't know that it was used that much. I think the only ground station is at White Sands, I think. So you only have coverage part of the day and then only if the weather is good. So there were a lot of people who were disappointed with the poor video, but I guess they had to use the bits for other things. Because they sent down some still pictures that are stunning. I don't know if you've seen them.
I've seen a few of them. Yeah. I didn't actually ever see the live video. What was it? Like just low frame rate or?
Yeah, the live video was very low resolution, low frame rate with a lot of errors. So I don't think the link was actually that noisy. I doubt it. Could have been, but there were a lot of artifacts, MPEG artifacts, or JPEG, whatever it was, artifacts.
Do you remember when they were running analog on the shuttle? They would just inject time code or something, just at some random ass location in the frame. You remember that?
The shuttle was all digital.
Well, no, they ran analog. Ran analog.
Well, maybe they ran analog FM for video, but I mean the voice was digital.
Right. But for the on the analog video, often just in the middle of the screen, just you'd see one line with bits, just doing their thing, just smacking the middle of it. And it varied randomly depending on what, where it got synced.
Okay.
Yeah.
I hadn't noticed that.
Yeah.
Check if you're interested in good video. There's some pretty good video on the NASA website, and more is appearing. They had a 360-degree view camera that you could that was placed north of the launch pad or south of the launch pad. You could watch. That was pretty impressive. Um, the eclipses and then the Earth setting behind the moon. Those were. I mean, that's already my desktop and my laptop. Oh, and that picture of the dark side of the Earth, it looked like daylight because the exposure was so sensitive. That was pretty good.
Yeah, you don't very often see an undoctored picture of the Earth lit up with stars.
Yeah, yeah. Well, at first I couldn't figure out what that bright limb was, and then I realized, oh, wait a minute, this isn't the daytime. This is nighttime.
Yeah, you see the sodium band, and you see the auroras, and
Yeah.
yeah.
So I can find it here. There's the problem is there are several versions, and you want to try to find the originals if you can. That have all the there are originals are available that have all the original EXIF data from the camera in them. They haven't been stripped out. I think they were running at ISO 50,000 or something. I didn't know cameras could go that high.
There was an interesting thing on Hackaday about that, or maybe it's Hacker News. They're using an ancient Nikon D5.
Yeah, well, ancient is like 10 years old.
Yeah, and they used it specifically because if you plot out sensor size and ISO sensitivity, it's the best.
Yeah, and they wanted that for especially for eclipses
because they knew it was going to be an extreme low light situation.
Yeah, Sony has some remarkable sensors out there. I think the Nikon ones use Sony sensors, but there's a I think it was Nikon was demonstrating a camera that could get usable results with like 1 or 2 million ISO, and
Wow.
it was
usable, huh?
Well, I mean, it is a bit noisy, but it was full of color on a moonless night. This is about 10 years ago, and then Sony had some cameras that do a reasonable job with stupid high ISOs as well. But yeah, there's that. I mean, there's that old problem of like a lot of the tiny cell phone imagers, you get like several thousand electrons per site, and
Yeah.
you're not going to get very noise-free pictures out of that. But I imagine an imager like this with some pretty big, huge pixels would probably have, tens of thousands of electrons per.
Well, quantum efficiencies in modern sensors are pretty good. I mean, if a photon hits it, you're very likely to see it.
Right.
Are you seeing the info pop up on this picture?
Yes.
Yeah.
Yeah.
So this is the original camera image. So it's got all the original Nikon D5, 14 and 24 millimeter f2.8. Was this a full-size sensor?
It is, yes.
Okay, so that's a wide-angle lens then for a full-size sensor because
it is.
Standard would be 50.
Let's see, what is this?
Oh, that was pretty early on. Yeah, so yeah, the Earth was still pretty big.
Yeah, let's see. What is the focal length? 22 mil? Oh, no, wait, 22.
Oh, there it is. Yeah, 22 millimeters. Yeah, 22.
The sensor
That's
size?
wide angle.
Okay, that's okay. And f4, okay.
f4, quarter of a second. ISO 51,200.
That tells you how dark it probably really was.
Well, the Wikipedia page says standard ISO goes to 100K, and you can boost it to 3.2 million.
Huh.
That's the sensor is a Nikon design manufactured by Toshiba. It's CMOS.
Oh, where is it? Oh, okay.
20 megapixel.
I have an ancient Canon 20D, I think it is. It's like 6 megapixels. I mean, it's less than my camera, less than my phone for a long time now. But if I buy something else, I'd like to reuse my lenses. Does Canon have anything like this? Of course, I just use my phone for everything these days.
Yeah, let's see. Carl Zeiss for NASA Apollo had a 50 millimeter 0.7 f.7 lens.
That's the one they used in Barry Lyndon.
Yeah, with probably zero depth of field. That must have been
Right. Where so let's see. Do you want to focus on the groove of your filtrum or on the edges of your filtrum from 10 feet away?
Well, that shouldn't be a problem here. You're focusing something many thousands of kilometers off, so focus should not be a problem,
Right.
or depth of field should not be a problem.
I have a one
Focus
point.
may be a problem,
I have an f1.4 a prime lens, a 50 millimeter, and that one's a chore to use if you want it wide open. You better bracket your focuses if you really want that picture.
yeah.
Foci, I guess.
This is a nice picture. I mean, you can see the top of the atmosphere all the way around because, well, in low Earth orbit, you see that green glow from, I think it's nitrogen oxide or nitric oxide recombination or something like that.
Let's see here. That's the isthmus. Isn't that the Isthmus of Panama on the lower?
No, that's over here. That is Gibraltar right here. That's
Gibraltar. Okay, that's the Mediterranean.
Yeah, that's Spain. That's Africa. This is Africa.
I do see a little bit of what looks like lens flare, just a little bit above and to the right of center.
Over here?
No, above and to the right of center.
Oh, there. Yeah. That probably is a reflection off a window.
Right. Yeah. Obviously, they're shooting it through a window. Maybe it's
shooting through a window. Well, they had these I don't know what we call them, covers around the lens to minimize
hoods
while they were taking pictures. They showed some pictures of that. But this is north down here, and this is south up here, so you can see both auroras, which is kind of cool.
Right.
And then I don't know where the sun was at the time, but it was probably around here somewhere.
And now is the time of year if you want to see the zodiac lights. Right around this time of year is one of the better times to see it because it's
zodiacal light.
Yeah.
Oh, there was some question about that in the pictures of the eclipse that they took, whether you were seeing the solar corona or zodiacal light. And
well, that picture you just had up, the zodiacal lights were in the roughly
in the lower right-hand corner. Yeah. Yeah, but the pictures I'm thinking of are, let me find some of these really good eclipse pictures.
Yeah, in the northern hemisphere at least, this is a good time for the zodiacal lights before sunrise. Because maybe a bit early, actually, probably February, March was better.
Was the dust is in the plane of the ecliptic, right?
Correct.
That why?
Yeah. And then it's at least in the northern hemisphere, roughly our latitude, it's during the spring, early spring, it's closer to being a right angle to the eclipse, to where the sun will track.
Yeah.
Just the way it looks.
Is this the one I want? Oh, I think, yeah, here we go. I think this is the one I want. Second here. Share this again. There we go. This is one of the, okay, there were a bunch of eclipse pictures taken with the outside cameras, which were GoPros. This is another one taken with the Nikon. This one with the long lens, though. At 80 millimeters. Okay, so they weren't that far. Yeah. ISO 40,000.
Now I do see some faint striations in that, roughly just above the 9 o'clock position. They're very, very faint.
So they're not quantization noise?
No. I mean, no, they appear to be radial to the almost radial to the disk of the Earth, but not quite at the right angle to the tangent.
That's the moon. This was the eclipse of the sun.
Oh, okay.
By the moon.
Okay, but I still whatever. Okay, the body that we're looking at. Yeah, I do see some striations there that I can't tell if they don't look. Well, yeah.
Well, there would be. I mean, if you're seeing the corona, you would expect that.
Right. So but you said that there were arguments, there were discussions.
The arguments is what is this stuff that's glowing? Is at first it was thought to be the solar corona, but then people think no, it might have been the zodiacal light. The dust in space that's being scattered forward by sunlight.
Well, knowing that if you knew the orientation of the camera precisely, you could probably work it out. But I do see some.
Well, we know what time it was taken. We know exactly where the sun was. We could
Right,
also
right,
consult a coronagraph that was taken at the time to see if it matches.
right. I guess if you know the orientation of the camera and the,
Yeah, and you know exactly where this was taken. It was taken after closest approach, and you're seeing part of the near side is being lit by Earthshine. That's why you can see the
okay.
this area here, and then the edge of the near side is about here, I guess. So this is all the far side over here, which is completely dark. Because they launched when the moon was full, and by the time they got there, it's a week or so later. So
Yeah,
it was completely opposite to the way the lighting usually was during Apollo, even the orbital missions.
I've used the line of you do a moon bounce on a full moon because there's more area to reflect the signal, and some people will actually believe that. Oh,
No,
that
I
makes
figure out
sense.
whenever. Well, when is perigee? It may or may not be.
Perigee, those are those like ravioli but filled with cheese and potato, right?
Yeah. Oh, perigee. I mean, moon bounce is a few dB easier perigee, right?
Right. Yeah. Yeah. I mean, it's what
I mean, it's enough. I make a difference for a lot of people. So this is a nice picture. Oh,
250.
at first, I thought that was Saturn because there was some chatter about Saturn. And I learned later that's actually Venus.
Oh,
I don't know why there's a streak, but
well,
I saw Venus yesterday. I was looking for it. I said, okay, yeah, it's close enough there in the right place to be Venus in that picture.
well, that's a good point because if that's a CMOS imager, well, I mean, you don't have the what is it, the well saturation problem that the
Oh, the bleed
CCD is
over along the readout lines.
correct.
Yeah, as you would have with the CCD.
Correct.
Well, I don't think that's actually that pixel might be saturated. I don't know.
Well, I'm sure it is blown out big time.
Is it?
Well, I
Maybe.
mean, it's got to be. I mean,
Well, yeah, Venus is pretty bright.
oh,
So
Venus is damn bright.
okay, yeah, I think you're right. Okay, I'm zooming in. I'm seeing diffraction spikes. So I don't know why I didn't do this before.
Now, some of the diffraction spikes are probably the aperture, but
Yeah.
and I'm saying two sets of images, so I'm wondering if that's interspecular reflections on the lens elements,
Yeah, this could be lens or in the window. I mean, they're shooting through
or
the window.
even on the imager itself.
Yeah.
I mean, you do have the problem. They do have to jump through hoops to keep the cover over the CCD from causing secondary reflections.
Yeah. Well, they're shooting through a window, and the window I know has multiple surfaces,
Oh,
so
that's true too.
there could
Yes.
easily be window reflections here.
Right. Right. Yeah, and it could be a slight streak on the window, maybe nose grease or something from everybody looking out of it.
They complained about that. They were having to clean the windows constantly because they were looking at them so much,
Yes.
and they had to do it again before the photography during the flyby.
I mean, it
So,
probably is nose grease then.
um, so let's see. This one here. This is a nice one. Now, this was a still, but it's obviously taken from one of the GoPros, the same ones that were delivering the video that was such low quality. So these cameras are capable of giving very good results. They just didn't have the bits for them.
Hmm.
I mean, that's an excellent picture. Look at the detail on that. I didn't quite know where all the antennas are. I was trying to figure that out.
Well,
I
there's
think
some.
these are probably
Those kind of look like antennas on the extreme far left.
on the left.
No, you zoomed out. On
Uh,
the far left,
where?
below the NASA logo.
Oh, here?
No,
Well,
below
that's a
no, to the right, to the left of the NASA logo.
the left of the NASA logo over here.
Yeah, those things sticking out.
Well, the things sticking out, I think, are the attachment points for the solar panels before they were deployed.
Oh, okay.
I know that the antennas are patches. I know there's several patch arrays up here somewhere, and this may be one of them. And there were also some on the service module, but I'm not sure where.
Years ago, Scott Manley did a blurb almost entirely on antennas on the Apollo spacecraft and space
Mhm.
shuttle. And
That was a lot more manual. This is the cover for the umbilical between the two that comes apart when they separated.
hmm.
I was amazed. We actually saw video of that separation. The service module continued to work, and you just saw stuff flying everywhere as it moved apart.
Hmm.
I could have seen this thing. I didn't know it. And I got the message too late today, but if I'd known an active duty Navy person who could be my escort, I could have gone down and seen this thing today.
Oh,
It's sitting on the ship in San Diego in the naval base down there. I'm sure it looks a little dirtier than this right now.
oh yeah. The Smithsonian seen the heat
Oh yeah,
shields
those
from some
things
of
are
the
really,
Apollo and
yeah.
Gemini stuff.
They're cannibalized too, which is really a shame. You look inside. There's one here in San Diego, the Apollo 9 capsules in San Diego. And you look inside, it's really sad. I mean, it's just empty holes in the panel, wires hanging out. It was
Right.
obviously cannibalized. So I think this is one of the here. I know there's at least two patches. I don't know a whole lot about phased arrays, but I mean, I know that, the geometry limits what you can do. This is probably another one here. I mean, the gain can't be as high when you're going at a acute angle as when you're going perpendicular. It can't be because the cross-sectional area is less projected area. So there are some nice pictures. It's just that they were sent down later as stills. They just didn't
Right.
have the bits for. Um, Somebody said this is the new Devo.
They're just not wearing the cones on their heads.
Yeah, right. Well, this is or around the time of the solar eclipse by the moon, which was 57 minutes long. That's quite an eclipse.
Hmm.
So yeah, these outdoor cameras were capable of giving some really good pictures. They just, I guess, used too many bits.
So some of those, like that looks almost like a
That's an attach point. That's where the panels were bolted down. I'm folded up, I'm sure. These things here.
oh, okay.
These thrusters, of course.
Right.
And I'm not sure what this.
That's something covering something.
Might be an antenna. Well, they have thermal radiators that they wanted to keep out of the sun, and for that, they usually kept the tail almost not quite pointed at the sun. This was a somewhat unusual attitude, so I suspect the radiators are on the sides somewhere. I mean, they can work in the sun, but you'd rather not do that if you don't have to. Oh, this shows the end of this panel. No, it doesn't, so you can't see another camera. But yeah, see, this is, I think, where the panels were attached
Hmm.
Before they're deployed. This whole thing was covered by fairings. I think there were three
Right.
sections. This whole thing was covered by a fairing that jettisoned during launch. You see them falling away. So yeah, the cameras had the pixels. It's just that the links didn't have the bits. It's really a shame, for this, they really ought to pull out the stops. Oh, here we go. I could probably zoom in on this one. Is that a GoPro? I guess that's a GoPro camera right there. So I think they had them on the end of each array. I don't see anything else that looks like a camera. That engine looks a little offset, doesn't it?
Maybe it's gimbaled a little bit. I don't know.
I don't know if it's gimbal or if it's just mounted to go through the center of mass.
I don't know. It's hard
What
to
I
tell.
do. Yeah,
Looking
it's
at the
hard to
root
tell.
of it, it's
Yeah.
I mean, I think it's probably. I mean, it makes sense that it could gimbal though
Yeah.
to compensate for whatever.
Yeah. Typically, though, you just have them mounted through the center mass. Although, the center mass can move. I mean, as the astronauts move, or stuff moves in tanks. So if you didn't gimbal it, then you might have to spend a lot of RCS propellant to keep it from, keep it
Right,
pointing in the right direction. You can see these thrusters have been fired.
but the main one not yet apparently.
Well, it's not discolored in the same way these are.
Yeah,
It's a characteristic how they look after they've been fired.
those are hypergolic, I presume, right?
All hypergolic. Yeah, they use monomethyl hydrazine. In fact, this is a recycled orbital maneuvering engine from a shuttle.
Oh, okay.
Basically, this is all done with surplus shuttle hardware. Four space shuttle main engines on the launcher that are thrown away. And the solid rocket boosters were basically shuttle hardware that was just lengthened. So this whole thing was a very expensive reuse of shuttle hardware.
Well, why the hell not?
Well,
I, I mean,
a lot of people are asking that question.
well, yeah. From a practical standpoint, the main thing that has changed between now and Apollo has been the computers that control the stuff, not the
Sure.
not the things that blow the gas out the end.
No, no. I mean, engines have hardly changed since 660. I mean,
Well,
the only real
what is it? The RD whatever Russian engines.
are, oh, yes, yeah, the
I mean, those are
RD-170.
ancient, and,
Yeah,
and they only still exist as a quirk because some guy in Russia or Soviet Union didn't follow orders to destroy the
right,
warehouse.
right, right, right.
Right.
Yeah. Um, there's some other, I got to go back. There must be many more now on or online, but I've been grabbing them as I come across them.
Hmm.
Oh, this was cool. The separation from the upper stage.
Boy, oy, 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 oy.
Yeah. Well, you see the springs.
Oh yes.
Well, the motion is the panel. I mean, you
Yeah.
could tell when they were working out. Whenever they were exercising, you could see the end of the solar panel was swinging a little bit. When they stopped, it was settled down. They didn't mention it, but I figured that out. It was very sensitive to that shaking. But yeah, look at all the dust, or I guess ice particles
Yeah.
separating out. And thrusters firing.
It's not like the Boeing capsule where a third of their thrusters just would randomly fail
Yeah,
or freeze up or
that thing seems to be a disaster.
yeah.
What else was I interested looking at here? I said this is just what I've been able to grab, and I'm sure there's a lot more now. Oh yeah, this friend sent me this. This was the airspace closure during the recovery on Friday.
Hmm.
There's San Diego. I live right about here. Well, there's KNY, KNKX. That's Miramar, so I'm right about here. So I was listening on UHF on the standard, the old Apollo and shuttle frequencies, but I heard nothing. So I guess they didn't use UHF on this recovery. When they talked to Houston, it sounded like they were using whatever they were using before. They were probably still talking through Teeters and S-band. But they had trouble using the satellite radios. At one point, Capcom asked them if they're pushing the PTT button.
Hmm.
I mean, the guy's a pilot and a ham. I think he knows how to use a PTT.
I didn't listen to enough. Did they even have the Roger beeps on things?
No, they did not.
Yeah, I didn't hear any. I just wondered.
Those were actually not meant to be Roger beeps. You know what the story is on those two tones?
Well, they triggered something.
Dark tones. What?
They triggered something. Forget
what
what.
they triggered was they triggered a muting relay at the uplink transmitter because the lines going there were all analog in those days.
Oh, okay, yeah.
And the astronauts would hear all the crosstalk on the phone lines if when Capcom wasn't speaking. I mean, he could turn his own mic off, but the lines were still generating noise, and it was being uplinked. So somebody added a relay at the uplink site so that could be that it could mute the uplink whenever Capcom wasn't talking, and then he would open and close the relay by sending those two tones, slightly
Yeah,
different pitches.
yeah. A Curious Mark on his channel did a pretty in-depth overview of.
Yeah, I got to meet that guy.
Yeah, I don't know what his call sign is, but
He is a ham.
oh yes, absolutely.
Oh, okay.
Yeah. Let's see here.
Is he Canadian? He sounds Canadian. Is he Canadian?
Well, he's French,
Oh,
but
French.
I think he's French.
Oh, okay. All right. He does sound French.
But I mean, I can't say that I have a really good ear to
Yeah.
between Quebecois and French.
Yeah, me
But
neither.
he doesn't.
I know there's a big difference. Yeah.
But I don't get the impression it's Quebecois because the real French, the
Oh, they
snobby
look
French
down
don't
on
consider
Canadian French.
Quebecois to be French.
Yeah, I know they look down on
Oh yes.
Canadian French a lot. Yeah.
And then everybody looks down on the Cajun French. So
Yeah. Well, Cajun French to me has always sounded like American speaking French, which they are.
right. Let's see here. Oh yeah, Alpha Juliet 6 Juliet Victor. AG6 JV is Curious Mark's call.
Thank you. It looked roomier inside, although it was still pretty cramped. Certainly roomier in Apollo.
Right. And looks even roomier if you have wide angle lenses.
Yeah. Well, it gets roomier in zero gravity also.
That's true, yeah.
Not sure what this was. May have been one of the burns. Yeah, you can see the solar panels wiggle. I was watching this when they did maneuvers or course corrections. You could also see the solar panels wiggling quite a bit.
So what percentage of I haven't really delved into the everything. I'm sure they used hydrogen oxygen fuel cells to some degree.
Oh, and this one, no, there's no fuel cells.
Oh, really? No.
All solar panel. No, that's what was a major change. I mean, I thought even during Apollo's time they should have considered solar panels. I mean, the Russians were using them, and now solar is the way to go. They got 11 kilowatts. Those fuel cells are not very powerful. I think they're only like 1, maybe 2 kilowatts each.
Well, yeah, didn't they? I mean, weren't they more or less in parallel with the batteries, though? I mean,
Yeah, the batteries were there that could handle peak loads, and then it had to be charged back up. They're silver zinc batteries. They can handle like a single-digit number of recharges over their lifetime, and they would do that.
Right.
The command module.
Okay. Yeah.
Most famously after the Apollo 13 accident.
Right.
They figured out a way to charge this command module batteries off the lunar module, by reversing the usual flow. I'm not sure what this was. This must have been a burn.
Yeah, I noticed there's a very slow swing back and forth.
Yeah, well, deadbands, right? You don't want to waste. There's no need to maintain a precise attitude when.
Right.
You just need to be close enough because cosine of small angle is 1. So. Yeah, you can see it very clearly in some of the launch videos too. But, what was this one?
You can, yeah, on some of the Apollo videos, I guess you do see, probably related to the finite resolution of the gyros and the extremely finite speed of the control computers when they're doing heavy maneuvers. Just the thing, just kind of doing this back and forth.
Well, the lunar module, remember the ascent stage in the lunar module had no gimbal.
Oh, okay.
You had to turn the whole thing, and so that any off-axis, if the thrust did not go directly through the center of mass, it would rock back and forth until it was corrected by the RCS engine. So that was just known. And that's very pronounced. If you watch like the video or the films of the ascents, they all do that. I guess it depended on where the astronauts were staying or how much they'd eaten recently or something like that.
Right.
It was a good aerial photography too of the launch. This was one taken from a Cessna, I think.
Yeah.
I've been trying to get the highest resolution versions of things. Let me find out what was this. Okay, yeah, this is this is 8K. Yeah, I was actually having trouble playing this because it's 60 frames per second too. I don't think I can even play this in real time.
4-minute video that's 6.4 gigabytes.
Yeah. This is the first time I've had a laptop that I haven't like quickly run out of space. It's a 4 terabyte drive. So there are a bunch of cameras down here, I believe, and there's some of those available also. They're pretty impressive.
I saw some of the launch pad cameras.
Yeah, see, this is not playing in real time. It won't render in real time.
Right.
It won't do it even without Zoom. It's not Zoom doing it. It's more impressive this way, I guess. Now, did they do a yaw maneuver?
Roll maneuver or
yaw, Y-A-W.
Okay.
I think maybe they are. I can't really tell. They're leaning away from the tower. The Saturn V did that by about a degree or so until it cleared the tower. A lot of people thought the rocket was going to fall over.
Or yeah, I remember that. I think it leaned and also just kind of crabbed a little bit too.
Yeah, that was the idea, was to scoot away from the tower in case of wind.
You see that on a lot of the what's the New Zealand company that launches rockets?
Oh, Electron?
Yeah, them. You see there on their launches. That's very pronounced.
Yeah.
I don't think it was Electron, but did you see that rocket? They tried to launch a few years ago, and they immediately lost one of the engines.
And it just moved sideways?
Yes.
Yeah, in Alaska. Yeah, that one. Yeah, I was just thinking about that one.
Yes, I mean, you got to give them credit. The only thing they were missing was thrust. I mean, the thing eventually did get up there, and it stayed perfectly stable. It tried to do it, it's a little rocket that could.
Yeah.
So it got blowed up, right?
Yeah. Well, this isn't so bad. It's playing smoothly, just slow.
Yeah. It used to be
videos.
It used to be at north of Grumman, which is where it used to be Thykol. They used to have, public exhibitions of the rocket booster testing. But
how could they be not be public?
Well, but when since north of Grumman has kind of acquired the place, they've kind of been much less willing to make it public. They're citing, of course,
well,
safety
I'm
concerns.
sure if you're anywhere nearby, you're going to hear them anyway.
Right.
Whether they want you to or not.
Yeah, I mean, the WebSDR site is within. If you can hear it very obviously from the WebSDR site if they set those off.
Yeah.
I've never been there when it happened, but the other guy has. I can actually hear it over the phone. He was on speakerphone when they set one off.
So yeah, this is all recycled shuttle hardware. Those are solid rocket booster segments from the shuttle. I think they added an extra segment to each one. And the core stage is basically an external tank that's been stretched, and the engines at the bottom are space shuttle main engines.
Mm-hmm.
So they're using once and throwing away in each launch. There's good video of the jettisoning of the fairings over the service module, and then the jettisoning of the launch escape tower.
Mm-hmm.
That came through really well. Okay, that was, I guess, all I have for that one. Oh well. I hate the beach ball. That's the thing that probably used up all my memory. One of the KPH machines got into a strange state last night. Rob sent me a text message, had me go look at it. KPH2 was thrashing like mad, using up all its swap space, which is pretty rare these days.
Mm-hmm.
something in the kernel had gobbled up all of memory for 8K buffers. We don't know what, but I have a feeling that something tickled a kernel bug that wasn't properly reclaiming this stuff when programs were killed and I had to reboot. But it kind of felt like this.
Did your computer, did it not free memory when you?
Something was they're called slabs. It's a kernel memory allocation mechanism used for internal buffering.
Okay.
Wasn't anything user. I mean, ChatGPT will help me walk through this stuff. And it wasn't anything that the user had done. It was internal kernel buffering that wasn't being properly freed when the programs were killed. He had Whisper Daemon running and something had run away and he wasn't doing concurrency control. And it was just the machine was in a sorry state. But usually, they recover when you kill the applications. This time it didn't because there was like no memory left. When I rebooted KNIQ Radio and all that stuff was working just fine, working normally.
I had trouble on KPH1 because that was the one that the shared memory filled up.
Oh, the shared memory filled up. Well, that's
what exposed that truncate bug on my shared memory segment.
Yeah.
The bus error. The bus error
different from this. That's
yes.
explicitly user allocated. This wasn't user allocated, or at least not directly user allocated. I'm looking at KPH1 now. It looks normal.
Yeah, KPH1, I think Whisper Daemon died, and so it wasn't deleting the old WAV files, but the WD record processes were still creating them, saving them to shared memory. So.
Oh, you're running PCM-record.bpsk now. What's that? You're running that on KPH1. Is that a test of?
Yeah, that's an older version of what the WD record is now.
Oh, okay.
I just threw that on the end of it so I know which one was which in user local bin.
Yeah.
That one's not running Whisper Daemon anymore, so I've got a cron job and it deletes the old files after it runs the cross correlation stuff.
Yeah.
It's doing the thing for Gwen where it's putting the first 50 milliseconds, I think. Instead of just finding the correlation peak, he wants all the correlation data.
I see.
I don't know that he's looked at it yet. Which reminds me, Clint, did you see the email that he sent out about that with the Northern Utah data from December?
Oh, you sent something out. You forwarded something just a few days ago.
That's it, yes.
Okay, yeah.
He said he did a presentation for one of the clubs in the UK, and he determined that it's, I guess, an extraordinary wave accounts for one of the time delays he couldn't figure out before. He seemed pretty excited about it all.
Well, I noticed he was always capitalizing the X, and I was trying to think, I was wondering, is that like X and O related, but there's no way to know polarity at Northern Utah because the antenna he's using is circularly polarized and most elevation angles. But anyway.
It's KPH1. It's running my latest code. You'll notice the priorities now. All the channels are, for some reason, it subtracts one or adds one and inverts, but I'm using priority 40 for all the channels, 40 one more than that for the FFT, and then top priority for the input routine.
Now, under Linux, priority numbers, the higher they are,
it's weird. Well, there's nice numbers and there's priority numbers, and the real-time system is completely separate. Nice numbers don't apply when you're running a real-time. But nice numbers to higher numbers mean less important. Like there we go. Start WWV start 19. There were nice 19. With real-time priorities, the numbers you give them are positive between 0 and 100, but for some reason here they're showing up as negatives. They add 1 and then flip the sign. So the more negative this number is, the more important it is. And if I could go down somewhere, I would see the routine that was servicing the IRQ, which is running at, well, it will show up as -51. There we go. See, there's a bunch of these real-time threads because this is a real-time kernel running at -51. And I was starving them by running the FFT at like 95 because I didn't know what numbers to use. But apparently this is a change in the real-time version of the kernel as they move this interrupt processing into a real-time thread, which makes sense because you don't want to spend a lot of time in interrupt context, because that's going to increase scheduling latency for everybody. So they moved them to real-time threads and gave them all priority 50. And then I guess I was causing my own priority inversion by, holding on to the machine when it needed to service the USB input, and was dropping USB data badly. At first, I thought I had a failed RS-888, and I swapped it, but the problem persisted. Then I realized I just changed the kernel. So this one appears to be healthy. That's KPH1. KPH2 is where this happened. Looks healthy now. I don't think he's running Whisper Daemon on anything. It's PCM record. That's probably mine. Yeah.
Yeah, Whisper Daemon would be running WD. Well, no, it wouldn't. Yeah, it would.
Yeah.
WD
I use PCM record to feed
FT4,
HFDL.
HFDL.
Well, I use the exec feature, so there's one copy PCM record that listens to all of the HFDL channels and then demuxes it into instances of dump HFDL, which you see. There's one of those for each band. So this machine looks healthy. It does bother me a little. I have all these threads, one for every channel. I thought about, restructuring it so there's some number of worker threads that go through all the channels, but it would be a major effort, and I'm not sure it's worth it.
I see some priorities listed as RT.
Yeah, I don't know what that means. I thought I'm RT, but I've only seen that in kernel processes. Maybe there's some special real-time level that only the kernel can use.
Well, it could be something that TOP is doing.
Yeah. I don't know what that means. So yeah, any of these, when the PR column, whenever that's negative, it means that it's a real-time process. Or it's using real-time scheduling, and there's several flavors of that. There's deadline scheduling, FIFO, and round robin. I'm using FIFO, which means I don't get preempted by timing. I may get preempted if a higher priority real-time thread becomes runnable and there's no available cores. I will get preempted. Otherwise, I'll run to completion. And because each of these things is using only, less than 1% of a core, it means they fire up every 20 milliseconds, run for a very short time, and then block again. So I didn't think it would even matter whether I use FIFO or round robin scheduling. The only one that runs for an appreciable amount of time are these two up here, the FFT and PROC-RX 888. And they still run, only half of the 20 millisecond slot or less. Yeah, see how decode FT8 appears and disappears quickly? That's all it's needed. Actually, there's two instances, one for FT4 and one for FT8. And so I had just one instance for each one doing all the bands. I don't really need more than that. If I look at the spool, oops. I keep forgetting an argument here. There's the spool files. You see how they're different sizes because they're different bandwidths. Then at the end of the 15-second interval, boom. That's how long it took to decode. See that? The temp, when the files are finished, the temp is dropped, and then the decode thread job wakes up, scans the directory and decodes everything, and it's like less than a second to do all the bands. So there's no need to have one, I keep trying to tell Rob this, you really ought to use some kind of concurrency control to limit the number of jobs you can have running at once. as it would ease things like swapping and cache pressure, memory and cache pressure.
Well, it sounds like you probably need to be telling Michael that.
Um, well, what's he doing?
Well, WD4 is going to use his Python library to do all that.
Oh, was he writing in? Well, I mean, okay, this is FT4 and FT8, and the easiest thing for me to do was to use PCM recorder to put these into files, and then have I modified the FT8 decoder extensively to just watch the spool directory for work, grab a file, decode it, and delete it. And I always thought that should be the way that WhisperD should work also. That way, if it falls behind, well, you're just using up some disk space until it can catch up. Although here, it's not a problem keeping up with FT8 or FT4. I mean, FT4 is even quicker. There, I'm only looking at fixed segments of each band. I don't, FT4 is not nearly as popular, so it hasn't spread out like the FT8 has, especially on 20 meters. So you can't even see the decode for FT4. I mean, it's quicker than a second.
Oh, I had a question for you, Phil, completely unrelated.
Yeah.
I sat in on the WWV working group meeting last week.
Yeah, I was there.
Yeah. And the guy from UMass was presenting his proposal for the new scientific modulation signal. And he kept talking about how the Gaussian noise segment of the current signal was really terrible for signal noise ratio. And I think he mentioned using uniform. Is that just like when I think of uniform, I think of the RAND function in the C library? Every one is equally possible.
Right.
Gaussian, it's the bell curve that we all know.
Right.
So is the reason the SNR that much worse for Gaussian because so many of them are near the center of the bell curve, and so you can't increase the level without overmodulating the transmitter because you've got those rare excursions at plus or minus 3 or 4
That's
standard
a good
deviations.
question. I mean, you'd want a flat spectrum, which would imply Gaussian.
But he was saying the signal noise ratio is terrible with Gaussian compared to uniform.
Yeah. Well, I mean, AM transmitter is going to waste so much power on its carrier no matter what you do. I had to think about that. Because I did recommend that use PN sequences for everything here, but Christine they wanted to do everything, wanted to, I guess, have a little bit of everything, which was good for a first signal, but I think they should go to a pseudo-random signal now, a noise-like signal. Let's see, anything to get rid of here? I think 107 is the latest of the real-time kernels. Yeah, low latency. That's what they call the real-time kernel on Ubuntu, at least for
Well,
6
there's no standard. Everybody's got a different name.
Yeah. I wish you'd could update all these, convert all these machines to Trixie, but it requires being there and it's a major undertaking. Some of these are really old. It's not the oldest machine I work with. There's one at the ATA that is running like, I don't know, some version of Ubuntu that's like 8 years old and nobody's updating it. And I have the root password, but I kind of hesitate to do that because I don't want to break anything. I'm a guest there. Anything over KPH1. Yeah, these are old. They have their own naming scheme. So apt will use staging by default under Ubuntu. It doesn't always install everything it could install. I guess for very large commercial networks, that's a good idea. But for us, it's just kind of a nuisance. So all these machines now have net 44 tunnels. Here's the tunnel down here, WG0. So you see it's got a network 44 address. And if I do
Yeah, I
this,
tried it out.
so yeah, it should work. I mean, there's a little extra latency because everything's going through Dallas. The nearest pop they have is in Dallas. They've got Dallas, Toronto, and Frankfurt, Germany right now. I've recommended a few more. I mean, the US West Coast plus something in East Asia would be good.
Dallas is good for me, actually.
Well, yeah, good for you. Yeah. I'm using the one in Toronto for VY0 ERC, but that really kind of depends on where the Earth station is for Starlink. And their network's kind of opaque. I haven't really seen a discussion of how they route stuff through Starlink from satellite to satellite and down the ground stations. I assume they try to get it down to the ground as soon as possible. So I'm assuming that if it's a stations in northern Canada, that Toronto is probably the best place and does seem to give the best ping times.
Are they carrier grade NAT?
Yes, they are. It's very great now plus IPv6. They do give you IPv6, although at VY0 ERC, it's blocked. It's filtered in their switch. They also have a subnet address conflict that I told Pierre about yesterday. So here's VY0 ERC. I brought up a tunnel there also. And you'll see that their Ethernet, their main station network is 192.168/16, you see. So they're using all those subnets. And then down here, they're using the .1 subnet for the Wi-Fi, which goes to Starlink, probably because that's the default that the Starlink route. I mean, this is an extremely common, default subnet for small routers. So I'm not surprised they're using that. So he told me about some NTP servers that were available at 192.168.1. something, and I couldn't reach them because they're all going over Wi-Fi instead of Ethernet. So I add manually some routes. Let's get rebooted. No. Oh, here it is. Okay, yeah. Wait a minute. I did some games with routing and I was able to talk to their NTP servers. It's just sources, I think. Yeah, their local NTP servers seem sick. I mean, one of them is like 7,000 days off and it supposedly has a GPS. I tend not to like to reboot the polar stations unless I know somebody's nearby. I killed DP0GVN for about a couple of weeks ago, last month, you may recall. Yeah, I must have taken this route out. But if I do something like this, I want this to go to EMP1S0. There we go. I don't know what happened to that route. They took it out. There we go. Yeah, see, now it's able to reach that again.
Yeah, I see the reach coming up.
What?
I see the reach is starting to roll in.
Yeah, but you see, I was wondering why it wasn't tracking it, why it was still using this guy This is an IPv6 address, and it's talking to it over Starlink, so it is able to talk outbound using IPv6, but I'm not able to reach it probably because the default firewall is off, and I can understand that. But then I realized this is why it's not using that one, even though it's supposed to be a Stratum 1 server. It's local to them. It's off by 7,168 days. That's an odd number. What is 7,168 days?
Is that multiple week number rollovers? That's
I
really weird.
wonder. I just thought of that. No, wait a minute. That's a week rollover. You might be right. Divide what's 7,168 over 7 is 1024. Yes. So it's off by 1024 weeks. It's a week rollover problem. That's why. Ha.
I bet you. I wonder if it's wonder. I was just when you first said it was 7,000 weeks off or whatever, 700, whatever.
It's exactly 7,168 days off. And it was also 7,168 days off yesterday.
Yeah.
And I
So
realized, okay, that's that's 1024 weeks. So the GPS that they have is not set to the proper rollover interval.
yeah,
Let's see.
the HPZ 3801s will do that unless you tell them otherwise.
Okay, they may not be aware of this. I'm gonna tell EMP1S0 host. When I wanted to look at everything.
Well, if it's an old enough time server with some ancient GPS in it, there may not be a fix.
Well, you can go and probably, I don't know, for all I know, there's probably a hack that lets you do it. Transmit timestamp 1982-05-02. You see that? Wait a minute, that's two, there have been 2 week rollovers, right?
Well, yeah.
Wait a minute, original timestamp 1939. Wait, something is very strange here.
I've run across that, and if you can log in and tell it what time it is, usually they straighten themselves out. But
Yeah.
if you do a total reset, like full, they lose the RTC battery or something like that, then
Yeah.
you do exactly what you, yeah.
Oh, this one's weird too. Oh, wait a minute, I'm seeing. What am I seeing? Is this me? That 31? I think that's me. Yeah, I wanted to see the ones from 1.20. So this one, 1999, 06, 27. Wait a minute, we had a rollover in 1999, right? 1980. So I don't know why these original timestamps are all over the place.
Yeah, there's one from 1959.
I saw that. 1970. These are like pseudo random.
Thought I saw 39 as well.
It's very strange.
I wonder if that's like a router.
A31.
It's also acting as an NTP server and it's just buggy.
Well, it's claiming to be Stratum 1. Who knows what it is? Reference GPS, it says.
Did you look up the OUI?
Oh, that's an idea. Well, I can also do this. I figure out what kind of machine it is. Let's see if it's a standalone server or a Linux box or something. Let's see what else it's running. Oh, it's got a web server on it. Oh, now I have to figure out how to talk to it. How am I going to do this?
Normally, I would set up an SSH tunnel as a.
That's about what. That's exactly what I was. That's exactly what I was about to do. It's got just a web server on it. It's probably wide open. I could probably fix it for them. But you wanted to know the. Let's see. That one right there. What is that? Yeah, how do I find this? Who is doesn't know this, does he? No.
IP neighbor, IPN.
Oh, does it have a table of?
Yeah, it's an ARP table.
Well, yeah, but yeah, I had the address. I now want to find out who made it. Who's the manufacturer? I thought that's what you were asking. Who's the vendor? 0003F4, whoever that is.
Okay, 0003F4. NetBurner.
Who's that? Who's that?
NetBurner is an embedded board. I think they're mainly based on the old Motorola Coldfire chip.
So does that mean this is a dedicated NTP server?
Yes, it's not running Linux.
Well, it's got a web server. Now I'm really tempted. What is this thing? Set up an SSH tunnel. I've done this. What a hack. Let me stop sharing again. Use more easily here.
Being a NetBurner, it's not the router. It's going to probably be a dedicated NTP server, but it's very low.
I think you're right.
It's probably 10 megabit.
So it's SSH minus L123. That should work. Okay, so now point my web browser at 127.001.123.5. Hey, it worked. Hey, Brandywine Communications.
They're broadcast.
They're broadcast equipment maker.
Yep, I've seen them before. Yep, I've seen them at television stations for.
There you go. Now I got all these pop-ups. Okay, here we go.
What is it?
Eureka, California.
What time does it say it is?
The version of the software is 2004.
Well, I'm just thinking about the time tab on the top.
Yeah, okay, I'm gonna get there. Baud? Does it have an external GPS that is serial output? Oh, it generates I see, it generates the date time on a serial stream. Okay, I don't need this. Display. I don't care about that. Password.
Not apparently.
Apparently. Reference. GPS. NTP. So.
It's unfortunate that it doesn't have a anything related to setting year offsets or week offsets.
What is
You'll
this
notice
thing?
there's nothing next to reference stable.
Yeah.
It doesn't say locked.
This window come up? It popped up a window.
It's not showing here.
Okay. Well, it says you must have Java support to view this. So apparently I don't have Java. How do I have
From
Java?
04, what do you expect?
Yeah, exactly.
If I use it.
How about Shockwave Flash? That would be.
You can still get Java on a web browser, can't you?
I think so.
Anyway, it popped up a box that says you must have Java support to view this. Then it says position mode tracking, and then there's a close button. So that didn't help much.
Well, I wonder if any of those NTP server. You'd think that it would get the year data from an NTP server. In that.
Yeah, you think so? That would be a logical thing to do. And
I wonder if any of those are going concerns.
There's a help screen.
Exactly. Yes, those servers may be dead.
Well, the other thing too is doesn't Cisco block NTP these days? Period.
Do they?
I think. Well, NTP is one of those bastard childs nowadays. I mean,
everybody relies on it.
Well, right, but I think it is almost forbidden to propagate it across the internet these days.
No, I mean, I use it all the time, and they're public servers. I mean,
a lot of people block it entirely, though.
Well, I'm seeing, okay, the only reason this thing has time now is because it is getting it over Starlink.
Right.
It's getting NTP just fine. It's just over Starlink, and I thought if they had a local NTP GPS receiver, it would be, more accurate, more stable. Let's see.
Does it have a Bodnar attached to the USB port?
Let's see. Um, no, I just did an LSUSB in another window, and it says Seagate hard disk drive and an R888. Nothing else on here other than the built-in stuff.
Right.
Oh,
So it's the standard configuration.
I just went to the 174.142 address in a browser and it's somebody's cat pictures.
Yeah, the question is, does it speak NTP?
I have no idea. Traffic
Let's see, there's
statistics.
a tool for
It's
that.
apparently umail.furryterror.org is what it is now. I mean, it looks like I'd be surprised. The first address doesn't resolve. Well, there's no web server there. Who knows? I would be surprised if none of those are working.
I'm just curious now. Let's see what's I'm asking ChatGPT. Let me just command a query an NTP server without setting local clock. NTP date minus Q. And then queries the server. Okay, did not set the clock. All right, NTP date minus Q. And I'll do this on VY0B And it's 140.221.8.88.
159 is live.
Oh, I don't have
140
NTP
is dead.
Oh, well, I guess his question is it reachable from there?
174 is dead.
First, I have to get, I'm doing it from there, but first I have to install NTP date on this machine. Okay, here we go. Let's try it again.
Of the
Okay,
three,
140.221.8.88 does not return NTP.
Confirmed.
Yeah, at least up internally, 159.203.8.72.
That one's good for me.
That is alive. And it is accurate.
Yeah.
Confirmed. Yeah, if you go there on a web browser, that's what you get is the time.
Okay. And then the last one, 174.142.148.226.
That one's good.
That's working too. Yeah. So only the first one is not working.
So the bottom 174 does return time?
Yes. The only one that does not is 140.221.8.88.
Okay, so apparently the firmware
it's see the first one 159 that's Stratum 3 and the 174 is Stratum 2, but of course both of those are over Starlink, which is what I'm trying to avoid.
But it's interesting that they're getting that device apparently is not reporting the correct year.
Yeah. It could be getting it from the GPS.
Well, yeah, I mean, one would hope that the weak rollover would be corrected by a second source of data, the NTP, but apparently it doesn't.
Well, that would be smart, right?
Right.
Yeah, but when they wrote this, they figured, it's 20 years off. We don't have to worry about it. This software won't last that long. I'm having trouble updating this. Why is it not responding? No route to host. Oh, my route's still there. Uh-oh. Did I do something to it? It's no longer answering pings. I do have my, oh, something just happened. Now it's answering. And I didn't do anything. So what is this thing?
Well, go back to the setup. I think it just.
I'm on the setup page now.
Oh, are you? Okay. Oh, okay.
Yeah. NTP to serial. So it looks like some kind of general purpose clock server. It can produce a serial time code. And I don't know if that's being used. I don't want to disturb that. That's the format for what it spits out on its local serial port. I don't want to affect that. Display. I guess it's got a clock on it. Don't want to change that. Select reference GPS.
Does the help? I wonder if the help would.
That's the one that wanted Java. No, wait a minute.
Okay, well, I was hoping it would say, thank you for purchasing a Brandywine. Blah, 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 blah.
Right here, we want to register your warranty. Network time display uses installed GPS receiver. Must be installed for this option to function. Does it though? Connected into the server as well as client. I see. It's just I have a general purpose network timing node here. They can have a GPS receiver, or it can just relay time from another server. Well, I haven't changed any configurations. I don't want to do that. That's something obvious. Oh, well.
Oh, Brandywine does sell a few those, but on the currently, the NTP 800 and the PTP 800, I don't. But who knows what this is, because this is 22 years old, at least.
Yeah. Now, I just used NTP date to query this thing to find out what its ID at the time is. 2006, August 29th is what it thinks the date is.
Okay.
Which is many seconds behind what a local machine thinks it is. But it claims to be Stratum 1. Well, at least there's no leap second depending.
Well, I mean, is that 1,024 weeks off, or?
It probably is. Well, actually, it's on a different window here.
Let's see here. How many years is 1,000? 1024 divided by 52. Well, 19.69 years.
Yeah, that's right. That's a rollover period.
Right.
We've been through 2 of them already, which is unbelievable.
Yes.
I remember the first one. I remember thinking it was a warm up for the Y2K problem. Yeah. Now let's see if I want to share this other window. Just the one I got here. Yeah. Okay. Yeah, I just did a query running on our machine up there, and asked this box what time it is, and that's what time it says it is. So there's an offset here. This is the error, or the difference between it and its local clock time. And that's probably in seconds.
Well, the time in the hour, minute, and UTC is probably right.
Yeah.
It is 405 UTC.
Oh, let's see, 405.30. Yeah, it is. It is. Okay, so it's probably tracking GPS. It's just off by 10, 24 weeks. Well, I'll send another message, Pierre. Giving all this free network consulting here.
Well, I guess the question is, does anybody know where the box is located? If it's that
somewhere
old,
in Eureka, Canada. Somewhere in Eureka, Canada, 80 degrees north. That's all we know. They might have been having, I don't know if this is being used for anything else or if they've been having problems with it and didn't know why, but maybe I can solve a problem for them. Yeah, I'm going to send a mail on what I found.
Yeah, if they're really, really lucky, they can remotely update or they can update the firmware. But
Okay,
and there's
internet
something
hasn't
new.
expired yet. Wow.
Brandywine Communications does mostly clocks, apparently.
Yeah.
Yeah, I've seen them in the broadcast at transmitter sites and whatnot. I wouldn't be surprised if the TV stations that are GPS locked use these for frequency stability.
Um,
Did
controlling
you
the
check the
transmitters.
router? It may have an NTP server. Or is there one?
What?
Is there a router on the LAN that you can access?
Well, one of the things I did was to run just a watch for broadcast packets or
Oh, okay.
were port 23, and I found a bunch of them, but none of them were. This was the only one that was Stratum 1. Um, let's see. I think that's right. Port 123. Screw you. Okay. Yeah, there's one. I didn't get the code. There we go. Okay, so there's a bunch of out there. They're actually multicasting the time, which I don't like to use because you don't know what the network round trip time is. But you see Stratum 3, Stratum 0 unspecified. Oh, that's me. There's the .21. That's the one. Yeah, it thinks it's Stratum 1, but it thinks the time is 1965, but 2006. Yeah. Yeah, it's spitting out time. It's 20 years ago or 1024 weeks ago. So these guys are spitting out, these guys are spitting out correct time, but they're not primary references.
Spitting out a time prior to GPS's invention seems like there's something else going on.
Something else is wrong. Yes, yes. I'm going to include this in my mail to him.
Yeah, 1925-09. Yeah, 1925. Yeah, that's
Explain that the GPS weak rollover problem is the GPS equivalent of the Y2K.
yeah.
It is a little disappointing the web page for that device didn't bother giving you the model number or serial number.
Yeah, and no way to set the weak number.
Well, that part doesn't surprise me.
Yeah.
Yeah, I've seen them that will let you just set, just put in the current date and time, and it figures it out from there. as I was saying, the Z3801's firmware is smart enough to do that.
Does it survive a power cycle?
If you don't leave it off too long. I think it has a super capacitor in it or something. But I think it's stored in, it uses I think it uses Motorola Encore receivers, which are, if you know about GPS receivers, those are truly ancient at this point. And I think that is what you're actually setting.
Doesn't someone make a retrofit for some of those old ones?
Probably.
Because they're used in so many weird places that you can't fix, you can't replace, so you have to replace the GPS.
I mean, I had to replace the GPS on mine one time, but that was like 20 years ago, so I was able to find the newer version of the Encore. The trick is that it talks in some sort of weird binary mode. Motorola proprietary but documented mode to the HP, and you had to jump through some hoops, to switch it to that mode.
When was the last GPS rollover? First one was in 1999. I know that. And then when was the next one?
Let's see here. April 6th,
2019.
What?
April 6th.
2019.
Yeah.
You keep doubling. April what? 2019?
April 6th.
April 6, 2019. Okay.
The next one is 2038. So
Oh yeah, 2038. That's also going to be the Unix rollover.
Yeah, right.
it's not at the
Oh,
same.
that'll be fun.
Oh man, it's gonna be a fun year if I'm still around then. It's gonna be fun.
It's not at the same. It's not the same day, of course, is it? Just the same year.
I think it's well, I mean actually that's a good question. When is the rollover? And
It says January for Unix on the year 2038 problem, and the week number will be November.
Yeah, there it is. Yeah, 19 January 2038 after 314 UTC. There's a great XKCD comic from years ago about how these nanites, which were eating the Earth piece by piece, suddenly stopped multiplying when it was discovered they only had used IPv6.
What have you got? Do you have it up?
I don't have it up. Let's see here.
That's right. Well,
let's see here. Let's see here. I'm trying to embiggen it, but it won't. Oh, it did embiggen. Oh wait, I shared the wrong screen. How did the hell that happen?
gonna happen. I see XKCD.
Oh, okay. Okay, yeah, okay. Okay, yeah, that's the one. Yeah. Anyway, that's been some time ago. I don't know when that was. 685. Anyway, yeah.
I didn't finish reading it. What was the rest of that?
Oh, okay. Sorry.
What did you say?
Let's see. Let me.
Year 1998. Has he been around that long?
Oh crap! Where did it go?
Run out of what?
Run out of address. What do
Oh,
you mean run out
addresses.
of
Look, we
address?
should have migrated away from IPv6. Away from IPv6?
Yeah, years ago. That's the swarm of nanobots talking in the
Okay.
swarm.
Yeah.
What do you mean run out of addresses?
All
Yeah.
right. So a few cubic microns, huh? The year
Yes.
1998.
I think that's when IPv6 was proposed, wasn't it?
I was around then. It's about that time. I
Right.
mean, but it started gradually.
Well, still starting gradually,
Yeah,
sort of.
I mean, I was there for a lot of that stuff. I wasn't actively involved in it, but I followed it, and I knew the people working on it.
Yeah,
It was at the time it was called IPNG, IP the next generation. So
I see.
yeah, you can imagine what that was inspired by.
Oh, I can't imagine.
Yeah. Okay.
Anyway, I need to stand up and do a few things, and because it's much later. Well, it's quarter after 11 for Scott.
Yeah, it's going at 9:15 here, but okay.
All
Been
right.
fun, guys.
See you. Bye.
Bye-bye. See you, Scott.